This is the second series of non-stop numericals on mathematical economics. First question is, suppose a firm has short-run supply function as C is equal to Q cube minus 10Q square plus 17Q plus 64. C is the total cost, Q is the output. We have to find out the level of output which maximizes profit if price is being given us as 5. Okay? Options are being given, we need to find out the correct option. So what we are being given here, we are being given the cost function is C is equal to Q cube minus 10Q square plus 17Q plus 64. This is the cost function. Also price is being given us as 6. Okay, so let me draw a simple graph to make sense here. Let me draw a simple graph. What happens? So if I draw the graph like this, we have what we call the output on the horizontal axis, price on the vertical axis, and other marginal costs or other things on the vertical axis. Okay, now what is the condition for profit maximization? Since price is being given us is rather 5, I have written here 6, so we have here 5. So let us draw, since P is equal to 5, so our what we call this line will be a straight line parallel to output axis. So this is P is equal to 5. Okay, the condition for profit maximization, we know for profit maximization, our condition is that we equate the marginal revenue. In this case, since we have P, so we equate price with the marginal cost. Okay, so the condition for profit maximization in case of perfect competition is that we equate price with the marginal cost. Okay, so first thing is that we need to find out the marginal cost. Then what is marginal cost? That is the change in the total cost due to the change in the output. Differentiating the cost function with respect to Q, derivative of Q cube is 3Q square. By power function rule, if we have x raised power n, its derivative with respect to x will be n times x raised power n minus 1. Exponent becomes coefficient and exponent is subtracted by 1. Like if we have x raised power 5, its derivative with respect to x will be, so 5 becomes coefficient and this 5 is subtracted by 1, that is we get 5x raised power 4. Same thing I have done here. In the same fashion, we have derivative of Q square is 2Q, so 2 into 10 is 20Q, plus derivative of Q will be 1, so we are left with 17. So we equate price with the marginal cost. So this is our marginal cost, we equate with the price, so we have 3Q square minus 20Q plus 17 should be equal to price, which is 5. Solving, so we get 3Q square minus 20Q. If I transpose this 5, it gets subtracted. 17 minus 5 comes out to be 17 minus 5, so it should be 12 here, and we set it equal to 0. Since we have a quadratic function, we need to solve it using the formula, that is, so how do we solve a quadratic function? So we can write Q will be equal to minus B using the quadratic formula, that is we have 3Q square minus 20Q plus 12. Okay, using quadratic formula, that is, let us say this is the coefficient of Q square is A, coefficient of Q square is 3, which is A, coefficient of Q is minus 20, which is B, and coefficient we have the constant term C. Using quadratic formula, Q will be equal to minus B plus minus B square minus 4 times A into C divided by twice A. We know this formula. So we have in place of minus, so first we have minus from the formula, the coefficient of B is minus 20, rather minus 20, then we have plus minus. B square means the coefficient of B is minus 20, so minus 20 its square is 400, because minus the square of a negative number is positive, so we get 400 minus 4 from the formula times the coefficient of A. We have A is 3 and we have C, which is 12, divided by 2 times A, which is 2 times 3, so we get here 20 plus minus, so 400 minus, so here we get 12 3s are 36, so we have 36 into 4, so this is 4 6 are 24, 4 3s are 12, 13 14 15, sorry 4 6 are 24, 4 3s are 12, 13 and 14, 144 divided by 2 times 3, which is 6, or we will get 20 plus minus 400 minus, now we have 400 minus 144, so we have 10 is 6, 9 is 5, 3 is 256. Here we have 256 under root divided by 6. Now what is root of 256? So we have 256, its root is so making pairs from the left, so we have 1 1s are 1, so here 2 minus 1 is 1, so this doubles, so we get 2, then we take these 5 6 here. Now if I write here 26 into 6, so 6 6 are 36, 6 2s are 12, 13 14 15, that means under root of 256 will be 16. Okay, that gives us Q will be equal to, so we have 20 plus minus under root 256 came out to be 16, divided by 2 into 3 is 6. Now let me rub this here, I don't need this now. Since we have the quadratic equation, marginal cost is this stuff, so it will look like this. This is our marginal cost, okay, quadratic one. We will get two values for Q, obviously, so either Q is equal to 26 plus 16 is 36 divided by 6, which is equal to 6, or we get the value of Q. Q is equal to 26 minus 4, sorry 26 minus 16 is, sorry 20 minus 16, which is 4 upon 6, which is 2 upon 3. So we got two values for Q. Now we need to find out which of these satisfy the second order condition for maximization. Profit is rather for profit maximization, price should be equal to marginal cost. That means this price axis, it is intersected by the marginal cost at 2 points when Q is equal to 2 upon 3 and when Q is equal to 6. Between these two, we need to find out which actually maximizes the profit. So we need to find out the second order condition. Second order condition tells us that at the point of intersection of marginal cost and price function, the slope of the marginal cost curve should be positive. Okay, now we need to find out, we need to evaluate the marginal cost, the slope of the marginal cost at the critical point, which is 6, and at 2 upon 3. So what is slope of marginal cost function? That is the second derivative of cost function with respect to output. So this is first derivative, so this is second derivative, dq square. Now again differentiating with respect to q, derivative of q square is 2q, so 2 into 3 is 6q, minus derivative of q is 1, we are left with 20. Now we need to evaluate this at critical points, and we should get a it should be greater than 0. Okay, so when q is equal to 2 upon 3, d square c upon dq square, evaluating at q is equal to 3, let us see. So we have 6 times the value of critical point is first 2 upon 3 minus we have 20. Here 3 ones are 3 twos are, so 2 twos are 4 minus 20, 4 minus 20 which is minus 16, but which is less than 0. Now when, so this does not satisfy the second order condition for profit maximization, because at this point slope is what we call decreasing. When q is equal to 6, let's evaluate again at the critical point dq square upon dq, dc square upon dq square at q is equal to, so here we have 3 upon 2, rather 2 upon 3, here we have 6 this time. So we have 6 times 6 minus 20, so we have 36 minus 20 which is 16, which is greater than 0. That means at this point slope is increasing of the marginal cost. So this satisfies the second order condition for profit maximization. This does not satisfy the second order condition for profit maximization. At this point the slope of the marginal cost is decreasing, but at this point the slope of the marginal cost is increasing. How do we got this? Because here d square c upon dq square is less than 0, but at this point d square q, the second derivative of cost function with respect to output, here it is greater than 0. Next question is how to find out the utility maximizing bundle from the given utility function and the budget constraint. The question is, given the utility function is utility derived from the consumption of goods x1 and x2 is equal to x1 square times x2, and the budget constraint is, that is 5x1 plus 2x2 is equal to 300. 5 denotes the price of good x1, 2 denotes the price of good x2, 300 denotes the income of the consumer. Find the utility maximizing bundle. Options are being given, so we need to find out the correct option. Okay, so we use here tangency condition. Okay, let me draw the graph here first, or let me draw a simple graph. We have x1 on the horizontal axis and we have x2 on the vertical axis. Okay, now for utility maximization, what is the condition? So first order condition for utility maximization requires that we equate the marginal rate of substitution between good 1 and 2, and it should be equal to the ratio of the prices, that is price of good 1 upon price of good 2. Okay, so let us write something here. So price of good 1 is here 5, price of good 2 is 2, and income of the consumer is 300. MRS means the ratio of the marginal utility of good 1 upon marginal utility of good 2. It should be equal to the ratio, price ratio. Now this denotes, this MRS denotes the slope of indifference curve, and this P1 upon P2, this denotes the slope of budget line. So the endeavor of the, and I forgot to write here, we want to maximize the utility of the consumer, which is x1 square times x2, subject to the budget constraint that he faces, that is 5 x1 plus x2 should be equal to 300. Okay, so I should have written this firstly, I forgot, so I write it here. So our endeavor is to maximize the satisfaction of the consumer subject to his budget constraint. So with the given budget, let us draw this budget line. Consumer wants to reach to the highest possible indifference curve. Okay, so highest, this is IC1, IC2, IC3, and optimal bundle will occur where the slope of the budget line and the slope of the indifference curves are equal. It happens at this point where they are tangent to each other. That will give us the optimal bundles of good x1. Rather here we have x1 star x2 star. Okay, so x1 and x2 star we are supposed to find out. Okay, so at this point the slope of indifference curve should be equal to slope of the budget line. Slope of indifference curve means the ratio of the marginal utilities of good x1 and x2, and slope of budget line means the ratio of the prices of good x1 and x2. Okay, mu1 means marginal utility of good 1 means the change in the total utility due to the change in the consumption of good 1, that is the partial derivative of the utility function with respect to good x1, divided by mu2 means the change in the utility of upon the change in the consumption of good 2. It should be equal to the ratio of the prices. So we have 5 upon 2 here, 5 upon 2. Let's take the partials. Derivative of this function partially with respect to x1 means this 2 becomes coefficient, so we have 2x and exponent is subtracted by 1, it becomes 1, so we have 2x1 x2 divided by du upon dx2 means the partial derivative with respect to x2. Derivative of x2 is 1, so we are left with x1 square should be equal to 5 upon 2. So here 1x gets cancelled, which implies we get 2x2 upon x1 should be equal to 5 upon 2. Solving further, so 5x1 is equal to 4x2, or x1 is equal to 4 upon 5x2. Now we plug this value into the budget constraint. So we have 5 times the value of x1 is 4 upon 5 x2, plus we have then x2 again should be equal to the income, which is 300. 5 gets cancelled, 4x2 plus x2 is 5x2 is equal to 300, which implies x2 will be equal to 300 upon 5. So upon 5, so we get 5, 6 is we have 4 upon 5. So 4 2 2s are 4. Let me see if I have done it correctly or not. So here we have 4 of 5 gets cancelled, so we have 4 plus 1 is 5, so 5 1s are 5. What is the value of x2? So here it is, x2 should be 2x2. Okay, so here we have 2x2, sorry, we have here 2x2, that's why I was get confused. So here is 2x2, so this becomes 6. Okay, 6x2, so dividing by 6, so we will get 6x2 is equal to 300, implies x2 will be equal to 300 upon 6, so which is equal to 6 1s are 6, 5s are, so we have 6 zeros are, so x2 will be equal to 50. So we have x2 is equal to 50. To find out the x1, simply plug the value of x2 in this equation. So x1 will be 4 upon 5 times the value of x2, which is 50. So here we have 10, so 10 4s are 40, so it will be 40. Okay, so the correct option should be x1 x2. So x1 should be 40, x2 should be 50. So 40 50, so this option should be correct here. And how to find out the marginal cost from the given production function? The question is, a firm has a production function y is a function of capital and labor, that is y is equal to under root KL, and faces a wage rate of $4 and a rental rate of capital is $4 or so. We need to find out the firm's marginal cost. Okay, so what we are being given? We are being given the production function is, can I write it like this, k raised power 1 upon 2 times r raised power 1 upon 2. Wage rate is equal to 4, rental rate of capital is also 4. Okay, we need to find out the marginal cost for this firm. Okay, so to find out the marginal cost, what we need to do here in this case, we want to solve the question using the cost minimization principle. That is, we want to minimize the cost. What is the cost? Cost is the wage rate times units of labor employed plus rental rate of capital times the units of capital employed, such that k raised power 1 upon 2 times L raised power 1 upon 2 should be equal to the we want to minimize the cost subject to the production constraint. So graphically what we want to do, if we have labor on the horizontal axis, capital on the vertical axis, with the given production constraint, let us say this is our isocon, we want to minimize the cost of producing. Okay, so it will happen at a point where the iso cost and iso quantities are tangent to each other. Okay, so let us first solve it. So for optimality, our marginal rate of technical substitution between labor and capital should be equal to the ratio of the prices, price of labor upon price of capital. Now MRTS is simply the marginal product of labor upon marginal product of capital, and it should be equal to the ratio of the prices. Here we have price of labor is W, price of capital is R. Okay, now what is marginal product of labor? It is simply the change in the total production due to the change in the units of labor employed. So mathematically it means the partial derivative of the production function with respect to labor. Similarly, MPK means the change in the total production due to the incremental change in the capital. That is mathematically it means the partial derivative of production function with respect to capital, and it should be equal to the wage rate upon rental rate of capital. So wage rate is 4, rental rate of capital is also 4. Okay, now the partial derivative of the production function with respect to labor first will be, so the exponent of L becomes coefficient, so we have 1 upon 2, k raised power 1 upon 2 remains same, but the exponent of L is subtracted by 1, so 1 upon 2 minus 1 is minus 1 upon 2. Similarly, dy upon dk means the partial derivative of the production function with respect to k, okay, of the given production function. Okay, so in this case the exponent of k becomes coefficient, and the exponent of k is subtracted by 1, we get minus 1 upon 2, and L raised power 1 upon 2 will remain same. It should be equal to 4 upon 4 is equal to 1, which implies, so 1 upon 2 gets cancelled. So let us transpose this k to numerator and this L to denominator, so we will get k raised power 1 upon 2 into k raised power 1 upon 2 divided by L raised power 1 upon 2 times L raised power 1 upon 2 should be equal to 1. So since base are same, we can add the exponent, so we get 1 upon 2 plus 1 upon 2 is 1, so we get k upon L should be equal to 1, which implies k is equal to 1, rather L. Now we plug the value of k is equal to L into the production constraint here. Okay, for this let me see if I am within the limits. So I am here, so k is equal to L. Let's plug the value of k is equal to L, so we have L raised power 1 upon 2 times L raised power 1 upon 2 should be equal to y. So again base are same, we can add the exponent, so we get L is equal to y. Okay, if L is equal to y, k is equal to L means k is also equal to y. Now we plug the value of L and k into the cost function. Okay, so our total cost will be, let me see, rather I am in the limit, so our total cost will be equal to, so wage rate is 4, the value of L we got equal to y plus rental rate of capital is 4 and k is also y, which implies our total cost will be equal to 4y plus 4y is 8y. This is our total cost function. Now what is the marginal cost? Marginal cost is the change in the total cost due to the change in the output. Okay, so that is dy. So take derivative of this with respect to y, derivative of y is 1, so we are left with 1, which we will, here we will get 8 into 1, which is equal to 8. That means our marginal cost will be equal to 8. I hope how to solve a constrained optimization problem using Lagrangian approach. The question I have cut it short because of the lack of the space. The question says we are being given a production function, that is Q is a function, that is output is a function of two inputs x and y, which is equal to natural log of x square plus natural log of 4 times x times y plus natural log of y square. Price of input x is $1, price of input y is $1, and total cost incurred on the production of x and y, cost incurred on the inputs is $50. We have to find out the optimal values of x, y and lambda and interpret the meaning of the lambda, the value of the lambda that we will get using Lagrangian approach. Okay, so what is our endeavor here? We want to maximize the given production function, that is Q is equal to ln of x square plus, let me write it like this, ln of y square, then plus, then I will write ln of 4xy. Okay, our endeavor is, so graphically what exactly is meant by this? We are being given x and y are the two inputs with the given production isocount. So we have this production isocount. Rather, let me first rub this out. Good. Okay, so we want to maximize this isocount subject to the constraint that we are facing. That is, our constraint will be price of x times the units of x implied plus price of the input y times units of input y implied should be equal to the total cost, which is equal to 50 here. Okay, so price of x is 1, that is being given, times x, so 1 into x, so we have 1 into x plus 1 into y is equal to total cost is 50. So our budget constraint will be x plus y is equal to 50. Okay, so let me rub this. So graphically, what is our endeavor? With the given budget, let me draw the budget line. Okay, the firm wants to produce maximum output. So with the given budget, producers' endeavor will be to reach to the highest possible isocount. So our optimal bundle will lie at a point where slope of this isocost line is equal to the slope of the isocount line. Okay, isocount curve rather. But we have to solve the given question using Lagrangian approach. So in the Lagrangian approach, what we do, first thing is we set the given budget constraint equal to 0. So first step is, if I set it equal to 0, I will get 50 minus x minus y is equal to 0. Okay, first step is this. Second step is to multiply the given this result constraint by lambda on both sides, and third step is to form the Lagrange's function, that is L will be equal to, that will be equal to the given production function, what we call the objective function, that is, let me use the proper color ताकि तो ये पूरा है. So ln of x square plus ln of y square plus ln of 4xy yatlaj khai go dafa. Okay, so Lagrange's function is formed by adding the objective function and the resulting constraint that we have constructed. So then we have 50 minus x minus y. This is our Lagrange's function. Now to find out the optimal value of input x, y, and to find out the value of this lambda, what we do, we partially differentiate this Lagrange's function with respect to x, y, and lambda simultaneously and set them equal to 0. Okay, so first step is, what will we do? We partially differentiate ln of this Lagrange's function with respect to x. Okay, now let me do the partial differentiation here. What is the derivative of ln of x square with respect to x? So first, the derivative of ln of x square will be 1 upon x square. Then by chain rule, the derivative of x square is 2x. Okay, so I will get here x and x will get cancelled, so we will get 2 upon x. Derivative of ln of y square will be 0 because we are taking partials with respect to x. Okay, now the derivative of this ln of 4xy with respect to x, okay, will be equal to, so first the derivative of log function, we know it is 1 upon 4xy times the partial derivative of the denominator with respect to x. Derivative of x is 1, so we are left with 4y. 4 gets cancelled, y gets cancelled, so we are left with 1 upon x. Okay, so we get here 1 upon x. Now the derivative in the last, derivative of constant is 0. Derivative of x will be 1, so we are left with minus 1 into lambda is minus lambda, and we set it equal to 0. Okay, first thing, symmetrically, I hope I am doing it correctly, in this correct way. So ln of y, similarly we take the derivative with respect to y this time. So derivative of ln of x square will be 0 because we are taking partials with respect to y. Ln of y square will be equal to, so the derivative of log of y square will be 1 upon y square times the derivative of y square, that is 2y. So y and y gets cancelled, we are left with 2 upon y, plus similarly we have ln of 4xy, its derivative with respect to y this time will be, so first the derivative of ln of this stuff will be 1 upon 4xy times the derivative of this function with respect to y, so we are left with 4x. X gets cancelled, 4 to 4 cancelled, at we have 1 upon y, minus derivative of y will be 1, so we are left with minus 1 into lambda is minus lambda, and we set it equal to 0. Symmetrically we take ln of lambda will be equal to, so take the derivative with respect to lambda partially. So since no lambda is involved in the first 3 terms, its derivative is obviously 0, so the derivative of lambda is 1, we are left with 50 minus x minus y is equal to 0. Okay, I hope I am making myself clear. Having said that, let me save the space here. So if it is equal to 0, okay, so can I write it like this? If I transpose it here, it will become plus lambda. So let me use plus sign here, okay. So let us say this is equation first, this is equation second, this is equation third, dividing 1 by 2. Or if I further solve here, so we have same denominator, so 2 plus 1 is 3 upon x. 3 upon x is equal to lambda. Here it implies 3 upon y is equal to lambda. Dividing equation 1 by 2. So dividing equation 1 by 2, what will we get? We get 3 upon x divided by 3 upon y is equal to lambda upon lambda go lambda. So we get 3 upon x, transpose it to the numerator, it gets multiplied but reciprocated, so we get y upon 3 to 3 go cancel is equal to 1, so we get y upon x is equal to 1, which implies y is equal to x. Okay, now we have the options. We plug the value of y is equal to x either in the third equation or in the given budget constant that we have in this equation. So it will be easier to put the value here to get the value of x and y. So since y is equal to x, can I write x plus in place of y, which is equal to x again, is equal to 50. So 2x is equal to 50. 2x is equal to 50, which implies dividing both sides by 2, so x will be equal to 25. Plug again the value of, since y is equal to x, that means y is also equal to 25. That means the optimal values of x and y will be 25 and 25. Okay, having said that, nevertheless, what is the value of lambda? Now plug the value of x is equal to 25 y is equal to 25 in either of the first two equations, either here or here. Okay, so let us plug the value of x is equal to 25 here, so we will get 3 upon 25 is equal to lambda. So the value of lambda is equal to 3/25. So 3/25 क्या go? 3/25. Okay, so we have 325 point ये को 0 25 ones are 25 ये फिर सर हमें 5 25 okay, so 25 twos are, so we got 0.12. So the value of lambda is equal to 0.12. So what exactly is meant by this? The value of lambda simply tells us how much our output will increase when there is change in the constant of the constraint function. Okay, how our objective function will change when there is change in the constant of the constraint function. So constraint function is, so what is the constant in the constraint function? That is this cost function. It simply tells us how much our production will increase when there is incremental increase in the cost. It says simply what happens to the production when the cost increases by $1. Okay, so lambda is equal to 0.12 simply tells us when cost in this case increases by 1, when total cost increases by $1, that means output will increase by $0.12. I hope this is the interpretation of the lambda. It's how to find out the equilibrium level of change in income. The question is, assuming change in the investment, that is del I is equal to 25, marginal propensity to save is 0.5, the change in the income, which is del Y, will be equal to, options are being given, we need to find out the correct option. So change in the investment, that is del I, is equal to 25. Also the marginal propensity to save is equal to 0.5. We have to find out the change in the income. Now using the multiplier formula here, we can find out. Let's denote, K denotes the multiplier, which is equal to the change in the income due to the change in the investment, which is autonomous here. It is equal to 1/1 minus MPC, which will be equal to 1 divided by, what is 1 minus MPC? 1 minus MPC is MPS. Okay, because MPC plus MPS is equal to 1. Okay, so we have this equation now, del Y upon del I is equal to 1 divided by MPS, which implies del Y, we have to find out del I, that is the change in the investment, is 25, should be equal to 1 divided by MPS, that is being given us as 0.5. Can we rewrite it like this? Del Y upon 25 is equal to, what is 1 upon 0.5? It comes out to be 2, which implies del Y will be equal to, we have 2 here, if I transpose 25, it gets multiplied, it becomes 25, which means the change in the income will be equal to 50. So the correct option in this case should be this option, B option. To find out the value of the marginal propensity to consume, the question is, if the income increases by $5,000 million, increase in savings is $500 million, then marginal propensity to consume will be, options are being given, we need to find out the correct option. Okay, So what we are being given, the change in the income, that is the change in the income is $5,000 million. Change in the savings is equal to $500 million. We need to find out the value of the MPC, that is the marginal propensity to consume. Now we know that marginal propensity to consume is simply equal to the change in the consumption due to the change in the income, del C upon del Y. Also we know that the change in the income will be because of the two components, that is the change in the consumption plus the change in the savings. As we know, our income is either consumed or it is saved. Okay, so that means the change in the change in the income or will be equal to the change in the consumption if we take the differential on both sides plus the change in the savings. Now change in consumption is 5,000. The change in the consumption we are supposed to find. Change in the savings is 500. Solving for C, that means del C will be equal to 5,000 minus 500, which comes out to be 4,500. Then the marginal propensity to consume, which implies the marginal propensity to consume will be equal to the change in the consumption due to the change in the income. Change in the consumption we got is 4,500 upon the change in the income that is being given us is 5,000. So we will get here 45 upon 50, that is 45 upon 50, 45 upon 50. So this is 5 9s are 5 10s are. So we get 9 upon 10, which is equal to 0.9. That means MPC will be 0.9. Matrix, the question is, if B is equal to 1 3 4A is a singular matrix, find the value of A. Okay, so by singular matrix what we mean, we say a square matrix is singular if its determinant is 0. That means we have a matrix B which is square because number of rows are equal to the number of columns here. We say it is singular when the determinant of B is equal to 0. That means let's take the determinant of the B. By determinant what we mean, we multiply the principal diagonal elements first, that is 1 into A. From this we subtract the product of the non-principal diagonal elements, that is 3 into 4, and we set it equal to 0. So which implies A minus 3 4s are 12 is equal to 0, which implies A is equal to, transpose it here, it becomes plus 12. That means this matrix will be singular when the value of A is equal to 12. That means option C should be correct. Let's learn how to find out the slope coefficient in case of linear regression of y on x. The question is, if the estimated slope coefficient in the regression of y on x is beta hat, what will be the estimated slope coefficient in the regression of 5y on 10x? Options are being given, we need to find out the correct option. So let's understand it clearly. So what is the equation for linear regression of y on x? So the equation will be, that is y on x. What is the equation of y on x? That is y is equal to beta naught plus beta hat xi plus e, where y denotes the dependent variable, xi denotes the independent variables, beta naught denotes the intercept of the regression line, and beta head denotes the slope, and we are interested in finding out the beta head. So how do we calculate the slope? So beta head, which is equal to b yx, it is being given by, that is the summation of x minus x bar times y minus y bar divided by summation of x minus x bar whole square. Okay, and we are being told that it is equal to slope is equal to beta initially. Now look at that, means this whole stuff is equal to beta head, that is y on x. For this equation, y on x, slope is being given by beta head. Okay, so you know the things here. Now let's assume, or let's write it here. Let's denote x prime or x dash x prime is equal to, so we are being told that in place of x prime we have 10x this time, and in place of y prime we have 5y. Okay, now we need to find out 10x, that is slope coefficient in the regression of 5y on 10x. Okay, so let me write it here, 5y on 10x. Okay, that means we need to calculate the slope this time. So again, beta yx will be equal to, using this equation, so we have summation of, so in place of x this time we have 10x. Okay, so can I write it first like this, x prime minus x bar times y prime minus y bar divided by summation of, in place of x we have x prime again minus x bar whole square. Okay, that gives us, let's denote it by beta prime, that is new slope yx. So this will be equal to beta prime yx will be equal to so we have x prime, so in place of x prime we have 10x this time. Okay, sorry for the cacophony. So we have 10x this time, so 10x. Similarly, since x prime is equal to 10x, that means x bar, that is mean will also change. So if it is x, now this will become 10x, that means we have minus 10x times y prime is 5y minus y bar will be equal to 5y bar divided by summation of x prime is again 10x minus, so x bar, that is mean has changed to 10x, so we have 10x bar here. So can we write it like this, summation of, let's take 10 common in the first term, so we have 10 x minus x bar, here we take 5 common, 5, so y minus y bar divided by, here we take 10 common, so here we have square, so we take 10 square common, so we 10 square common, so we are left with now look at summation of x minus x prime, sorry, x minus x bar whole square. So can we rewrite it like this? So 10 5s are 50, so we will get here 50 divided by 100 times the summation of x minus x prime times y minus, sorry, I am looking at prime, it is bar here, so summation of x minus x bar whole square. Now you know that this comes out to be 1 upon 2, so we will get here 50 upon 100 is equal to 1 upon 2, which is equal to 0.5, and you know this stuff is in fact equal to this stuff, which is equal to beta head. So this will be equal to beta head. I hope I make myself clear. So the correct option should be 0.5 beta head. Okay, so simply 50 upon 100 is equal to 0.5 times beta head. So the new slope, estimated slope will be 0.5 beta head. A problem on Cournot duopoly model. The question is, an industry has two firms, each of which produces output at a constant unit cost of $10 per unit. The demand function for the industry is given by, that is Q is equal to 1 is 10 is 100,000, 10,000, 100,000, million. That is 1 million upon P. Find the Cournot equilibrium price for the industry. Options are being given as 5, 10, 15, 20 and 25. Okay. So what we are being given? We are being given, we have two firms. So we have two firms Cournot model here. And we have a constant unit cost. That means our marginal cost is constant. That is $10 per unit. Demand function is being given, that's market demand function is being given by this very function, that is Q is equal to 1 million upon P. We need to find out the market price, Cournot market price at equilibrium. Okay, so if we can visualize the given demand function, it is actually what we call the rectangular hyperbolic demand function, or it is a constant elasticity demand function. Okay, because if I plug here and if I write it here P into Q, transposing it here, it will be 1 is 1 million. That means our total revenue will be constant here. So it is our constant elasticity demand function. And what is the price elasticity of demand in this equation, rather in this demand function? It will be equal to 1. Okay, so let me first explain why I am trying to find out the price elasticity of demand. Because to solve this this Cournot equilibrium, when we have the rectangular hyperbolic demand function or constant elastic demand function, we will require the price elasticity of demand. So let's first find out the price elasticity of demand. So price elasticity of demand is dq upon dp times p upon q. You know this very thing. dq upon dp means the derivative of this demand function with respect to p. So derivative of this will be equal to minus 1 million divided by p square, you know it, upon into p divided by what is q. Q is again this function, that is 10 is 100,000, 10,000, 100,000, million divided by p. Okay, so p, this p goes, or let me write it here, it becomes, I don't know how many zeros are here, enter, so transposing it here, it becomes p square divided by this stuff. This gets cancelled, this gets cancelled, so we are left with minus 1 is the price elasticity of demand. Okay, for any price, the elasticity of demand will remain constant. Having said that, now for equilibrium we know that, and also we are being told, let me write it first here. So marginal cost of each firm is being given as is $10. Okay, for equilibrium, what we do, we equate the marginal revenue with the marginal cost. Okay, now what is the marginal revenue in this case when we have the this kind of demand function? So marginal revenue, and let me write it here, marginal revenue will be equal to price 2 times price times twice the elasticity of demand plus 1 divided by this is the formula for calculating the marginal revenue when we have two firm Cournot model. Now what is this 2? 2 denotes the number of firms. Number of firms. In our case, the number of firms is equal to 2. So therefore here it is 2. Also this 2 also denotes the number of firms here. E denotes the price elasticity of demand. Price elasticity of demand. In our case it is -1. Okay. So for n number of firms in Cournot model, so we will have marginal revenue would be equal to price times n times the elasticity of demand plus 1 divided by n. Okay. Having said that, so our marginal revenue in this case will be equal to price times 2 denotes the number of firms. Here we have 2, so let's write it here 2, or let us write the formula first, twice E. Okay, so we are just calculating the marginal revenue first, and then we equate it with the marginal cost. So our marginal revenue will be equal to price times 2, since we have 2 firms here, so we have 2. What is price elasticity of demand? We calculated it as -1, then we have +1 divided by 2 times -1. So marginal revenue will be equal to price, this is -2 plus 1 divided by -2. So it becomes minus P into, now look at -1 upon 2, -2, this gets cancelled, so we get P will be equal to 1 upon 2, sorry, our marginal revenue comes out to be 1 upon 2 P. I hope I have done the calculation right. So this is our marginal revenue. At equilibrium, we equate marginal revenue with the marginal cost. Marginal revenue is this, so 1 upon 2 P should be equal to the marginal cost, which is being given us as 10. Solving for P, so P will be equal to 10. Transpose it here, it becomes 2, so 20 will be the what we call the equilibrium market price in case of Cournot duopoly. Now what is the output produced by each firm? So total quantity produced in the market will be equal to, so we have 1 million, 1 is 10 is 100,000, 100,000, million divided by the market price is 20. This gets cancelled, so we are left with 100,000 upon 2, which comes out to be 50,000. So total, no, BX0. So total output in the market will be equal to 50,000. Okay. Since we have the symmetric costs here, output of firm 1 will be equal to the output of firm 2. So they will separate it. So 50,000 upon 2 is 25,000. So each firm will produce 25,000 units of output. And we can also find out the total profit. We are not supposed to find out here. Okay. So the main thing was here, if we have what we call the constant elastic demand function in a Cournot duopoly, we use this relation to get the marginal revenue equaling marginal cost, and correspondingly we can find out the equilibrium market. How to find out the ratio of price to marginal cost in the Cournot equilibrium? The question is, Suppose that the price elasticity of demand for airline flights between two cities is constant and is equal to minus 1.5. If four airlines with equal costs are in Cournot equilibrium for this industry, then the ratio of the price to marginal cost in the industry is we need to find out. Okay. So we are being told that elasticity of demand is equal to minus 1.5, which is constant. Okay, so we have a rectangular hyperbolic demand function with constant elasticity, and the number of firms in the Cournot equilibrium, here we have Cournot industry is 4. Okay, and we are also being told that we have the equal costs. That means marginal costs are same for each firm in the industry. Now for equilibrium in Cournot competition, when we have constant elasticity demand function, which is market demand function, what we do, we equate the marginal revenue with the marginal cost. Okay, now what is marginal revenue when we have the constant elasticity demand function? So marginal revenue is simply equal to, that is price times n times e, and let me write it here, n times e plus 1 divided by n times e should be equal to the marginal cost, where n denotes the number of firms in the Cournot competition. So our price will be equal to, so price times n is 4, so we can write 4 times elasticity is minus 1.5 1.5 plus 1 divided by, we will have 4 times minus 1.5 should be equal to the marginal cost. Solving this, so we have P, then we have 4 into minus 1.5, it comes out to be minus 6. So we have minus 6 plus 1 divided by minus 5 should be equal to the marginal cost. Okay, now what will we get here? Agar मैं जाए ऐसे थे, if I can show it here. So we have minus 6 plus 1 is minus, here in the denominator we have minus 6, sorry. So we have minus 6 plus 1 is minus 5 divided by minus 6. So we will get P minus 5 divided by minus 6 should be equal to the marginal cost. So minus minus gets cancelled. So P divided by MC will be equal to 6. If I transpose 5 upon 6, it becomes 6 upon 5. That means the ratio between price and marginal cost in the Cournot equilibrium with 4 firms will be 6:5. How to find out the velocity of money? The question is, if the demand for money is MD upon P, which is the real money demand, which is equal to 1000 plus 0.2y minus 1000, or where P denotes the price, which is equal to 200, y is the in GDP, which is equal to 2000, and R denotes the rate of interest, which is 0.1. We have to find out the velocity of money. Okay, so what is our quantity theory of money? They tells us that money supply times velocity should be equal to the price level times the GDP. Okay, now at equilibrium we know demand for money should be equal to the supply of money. So money demand is equal to money supply. So let us first find out the money demand. So we have MD upon what is price. Price is being given us as 200, should be equal to 1000 plus 0.2 can be written as 2 upon 10. GDP is 2000 plus rather minus 1000. R is 0.1 and 0.1 can be written as 1 upon 10. This will give us the demand for money. So we will get here 1000 plus here we will get 400 minus here we will get 100, which implies MD upon 200 is equal to, so 1000 it is 1400 minus 100 is 1300. That means demand for money is equal to 1300 into 200, which comes out to be 1 2 3 4. It is equal to this value. 1 is 10, 100,000, 10,000, 100,000. Okay, so this is our money demand, and we know that money demand should be equal to money supply at equilibrium. So our M, money demand, is in place of M we have what we call this value times the velocity that is supposed to be found out. Price level is being given us as 200 times the income or GDP is 2000. That gives us velocity will be equal to, okay, let me see. So velocity will be equal to, so we have this 3 plus 2 is 5 zeros times 2 2s are 4 divided by this 26, and we have 1 2 3 4 zeros. So 1 2 3 4 1 2 3 4, these gets cancelled, so we are left with 40 upon 26, which gives us 20 upon 13 as the velocity of money. Learn how to find out the value of the government expenditure multiplier. The question is, given the ISLM model is C is equal to 100 plus 1 minus T times Y, where C denotes the consumption, T denotes the marginal tax rate, Y denotes the GDP. Investment is equal to 300 minus 0.1 R, where R denotes the rate of interest. That is, investment is a negative function of rate of interest. MD upon P denotes the real money demand. Okay, so this is the real money demand, which is equal to 500 plus 0.3 Y minus 0.3 R. That is, demand for money is the positive function of income and negative function of the rate of interest. If the marginal tax rate is 10% and real money supply is 1000, we need to find out the value of the government expenditure multiplier. Okay, now since we have the ISLM model, we know that at equilibrium what happens, IS should be equal to the LM. That means for simultaneous equilibrium, investment savings should be equal to the LM equation. That is, goods market and money market should be in equilibrium simultaneously. So first we solve for LM, that is money market. Okay, so we know that in case of LM what happens, money market is in equilibrium when demand for money is equal to the supply of money, supply for money. Demand for money is being given us as this very function, that is 500 plus 0.3y minus 0.3r should be equal to the supply of money, which is 1000, that is being given to us. What will we do here? We will solve this equation for rate of interest. Transpose we get 0.3y will be equal to 500 minus 1000 is minus 500, or I can write it as 0.3y minus 500. If I divide both sides by 0.3, we will get, rather we have 0.3r here because I have transposed this 0.3r. So 0.3r is equal to, that is, I will save the space, dividing both sides by 0.3, I will get r will be equal to y minus 500 upon 0.3. This will be the rate of, rather our what we call the LM equation. and I will not go into the detail what is meant by LM equation. It shows us different combinations of rate of interest and level of GDP where money market is in equilibrium. Okay, so taking theory apart, we will solve the numerical. Now we need to find out the goods market equilibrium. So in case of goods market equilibrium, which is to find out the IS equation, we know that our total income should be equal to the total demand or total expenditure, and Y should be equal to, so we have the consumption expenditure plus we have the investment expenditure and we have also the government expenditure. So our Y should be equal to consumption function is being given us as 100 plus 1 minus the value of T is 10%, which can be written as 0.1 times Y, plus investment function is being given us as 300 minus 0.1, or plus we have the government spending. So let us further solve. So Y will be equal to 100 plus 1 minus 0.1 is 0.9, so we will get 0.9 Y plus 300 minus 0.1, the value of R is this, Y minus 500 divided by 0.3, plus we have the government expenditure is G. Solving further, we will get, we have 100 plus 300, which is 400. So we have, or let us further solve it. So we have Y is equal to 100 plus 300, which is 400, plus 0.9 Y. Then we have minus 0.1 Y, minus into minus is plus, then we have 0.1 into 500 divided by 0.3 plus the government expenditure. Okay, so we have 0.9 Y minus 0.1 Y, so we have 0.8 Y. So we will get Y is equal to 400 plus 0.8 Y plus this stuff 0.1 times 500 divided by 0.3 plus G. Transpose it here, it gets subtracted, so Y will be, Y minus 0.8 Y is equal to 400 let me see if I have done it correctly. Actually we have 5,000 here. 0.1 is equal to 500. Okay, I have written it like this. So we have 400, but it should be 400. So let me see if I have done any mistake. We have minus R here. Okay, so minus 0.1, so here it is minus, sorry. So here we have minus 0, here we have minus 0.1 times 500. You can solve it, but I don't have the calculator here, that's why I am taking it as it is. So Y minus 0.8 Y is 0.2 Y is equal to this stuff, 400 minus 0.1 times 500 divided by 0.3 plus the government expenditure. Dividing both sides by 0.2, so we get Y is equal to 400 minus 0.1 times 500 divided by 0.3 plus G, and we divided by 0.2. Okay, now what is government expenditure multiplier? So government expenditure multiplier is the change in the income due to the change in the government expenditure, that is the derivative of this function partially with respect to G. Okay, so derivative of constant is 0, the derivative It is also here constant, it is derivative is 0, derivative of g is 1, so we are left with 1 upon 0.2, which is equal to 1 upon 2 upon 10, which is equal to 10 upon 2, which gives us 5 as the government expenditure multiplier. And how to find out the growth in output from the given Cobb-Douglas production function? The question is, suppose the aggregate output is given by this production function, that is y is equal to a times k to the power alpha times l to the power beta, where a is the productivity parameter and sum of output elasticities of output with respect to capital and labor is 1. If capital and labor each grow by 7% and productivity grows by 3% in a year, the growth in the output is we need to find out. Okay, so let us see what our production function is. Okay, so we have a production function, that is our production is a function of a denotes the total factor productivity. Okay, so it shows us the change in the output which is not explained by the inputs here. Okay, it is a productivity parameter here, times k denotes the units of capital employed, raised power alpha denotes the output elasticity of capital, how our output increases when there is 1 unit change in the units of capital employed. Okay, times L denotes the units of labor employed, times raised power beta. Beta denotes the output elasticity of labor, the change in the output due to the change in the units of labor employed. Okay, this is our production function. We are also being told that sum of output elasticity of output with respect to capital and labor is equal to 1. That is, alpha denotes the output elasticity of capital, beta denotes the output elasticity of labor, and sum of these is, that is alpha plus beta, it sums up to 1. Okay, also we are being told that capital and labor each year grow by 7%. That is, the growth rate of capital is equal to the growth rate of labor, which is equal to 7%. We need to find out the growth rate of output. Okay, sorry for my English. Okay, now given this production function, let's take log on both sides. That is, log of y is equal to log of a plus alpha times log of k plus beta times log of L. From the logarithm rule, you know it pretty well how to get it. Okay, if you don't get it here, I can make a separate video on this. Now if I take the differential with respect to the parameters, variables on both sides, that is the derivative of y with okay, so we take the derivative of y, that is 1 upon y times del y should be equal to, what is derivative of log of a? It is 1 upon a times del a plus alpha, derivative of k is, log of k is 1 upon k times del k. Similarly, the derivative of we have first beta, log of L, it is 1 upon L times del L. Okay, we can take that differential with respect to time also here. Okay, so making things simpler, we will get here, that is del y upon y should be equal to del a upon a plus alpha times del k upon k plus beta times del L upon L. Okay, now what is del y upon y? Del y shows the change in the output and y denotes the initial output. Okay, so how much output increases divided by the initial output, so it shows us the growth rate of output should be equal to, so this shows us growth rate of state of technology or productivity parameter plus alpha times del k upon k shows us growth rate of capital, plus we have beta beta times del L upon L shows us growth rate in labor. Okay. Now, growth rate of output, we are supposed to find GA, growth rate of the state of technology or productivity. It is being given us is 3%, so we can write here 3% plus alpha times growth rate of capital is 7%, so let's write it here 7% plus beta, the growth rate of labor is 7%, let's write it here 7%. Solving further, so growth rate of output will be equal to, we have 3% plus, let us take 7% common, we are left with alpha plus beta. Now we know that alpha plus beta, sum of output elasticity of capital and labor is equal to 1, so we will get growth rate of output will be equal to 3% plus 7%, alpha plus beta is equal to 1. That is, growth rate of output will be equal to 10% in this case. How to solve a linear programming problem using graphical method? The question is, we want to maximize z is equal to 4x plus 5y. X and y are the two variables, and we face the constraint that is x plus y should be less or equal to 20. Another constraint that we face, 3x plus 4y should be less or equal to 72, and x and y should be both greater or equal to 0. Okay, so what is the first step that we will solve this kind of question? First thing is, we need to draw the graph for the constraints. Okay, so first step is, we set the constraints equal to 0 and draw their graph. That is, let us plug, rather let's write x plus y is equal to 20. Okay, so we remove the inequality and first we plot this equation, which is linear obviously. By linear programming, what we mean, the linear programming is the problem of maximizing or minimizing a linear objective function subject to the linear constraints. Okay, so our endeavor could be to maximize profit or maximize revenue, so that will be the maximization problem. Or we could have the minimization cost, minimizing the cost, that can be also our objective. Okay, so our objective here is to maximize the given objective function. So in linear programming, it is actually a problem of maximizing or minimizing a linear objective function. Okay, so first step is, we set x plus y, that is, we solve the given constraints on graph. For that, we set the constraints with equality sign. Okay, so let us draw the graph of x plus y is equal to 20. Okay, so when x is equal to 0 in this equation, when x is equal to 0, y will be equal to 20. Obviously, when x is equal to 0, y will be 20, and when y is equal to 0 in this equation, so x will be equal to 20. Okay, so we also need to draw the graph here. So let us draw a simple graph. Let us say x is on the horizontal axis, y is on the vertical axis. So what we have the pointers here, so here you can see we have the pointers 0, 20, and we have 20, 0. Okay, so first term shows us the x-axis. So when x is equal to 0, y is equal to 20. Let us say this point is our 20. Okay, here x is equal to 0. Similarly, when x is when x is equal to 20, y is equal to 0. Let us say this point is where our x is equal to 20. Okay, so then we draw the line. This is for the first constraint. Now we have the second constraint. For that, let me pick another color. So we have 3x plus 4y is equal to 72. Again solving. When x is equal to 0, when x is equal to 0, that means this term is equal to 0, implies 4y is equal to 72. Okay, dividing both sides by 4, or y will be equal to, y is equal to 72 divided by 4, which comes out to be, so 72 divided by 4, we have 4 ones are 4, 5 6 is 7, 4 8s are 32. So we have point 0 and 18. So we have point 0 and 18. Now again we plug when y is equal to 0, when y is equal to 0, when y is equal to 0 in this equation. So this term is equal to 0 means 3x is equal to 72, or x is equal to 72 divided by 3. So here we get 3 2s are 6, so 3 4s are 12. Okay, so if I draw them in tabular form, so we have x, y. So when x is equal to 0, y came out to be 18, and when y is equal to 0, x came out to be 24. Okay, this is for the second equation. Now we need to draw the coordinates on the graph. So when x is equal to 0, y is equal to 18. Let us say this point denotes 18, and when y is equal to 0, x is 24. Okay, so for that I need to, let us say this point shows us 24. This point here we have 24, because here it is 20, so it will be to the right of 20. So our equation will look like this. Okay, having said that, what are our constraints? We are being told that x plus y should be less or equal to 0, 3x plus 4y should be less or equal to 72. Now we need to find out the feasible region. What is the feasible region? Simply, the feasible region is the area that satisfies all the constraints of the problem. That is, our feasible region will be the common area between the two lines. Okay, so x plus y, so our feasible region will be below the lines. Okay, so our feasible region will be this region, which is common to both the lines, because only this region satisfies all the constraints. Okay, so this shaded part is our feasible region, the area that satisfies all the constraints. Okay, so this cannot be our feasible region, because at this point we have x plus y should be less than 20, less or equal to 20, but we have another constraint, 3x plus 4y is less or equal to 72. So this cannot fulfill both the constraints. Similarly, this area does not fill both the criteria for the given two inequations. So only feasible region is this area. Now we need to check our objective function at the feasible points. Okay, so feasible point, what are our feasible points? This is our point. Let us say this is point A. Let us say this is our point B, because feasible points lie on the what we call the feasible region. So these are our feasible regions. And what are the coordinates of the feasible region? Here the coordinate of A is 0 18. Here, and the coordinate of B is 20 0, and the coordinate of C, first we need to find out the coordinate of point C. For that we solve this equation and this equation. Okay, so from equation first, can I write x is equal to 20 minus y? We use the substitution method here. Then I plug x is equal to 20 minus y in this equation, in the equation second. I put it in second equation. That will give us 3. The value of x is 20 minus y plus 4y should be equal to 72. So we have 3 2s are 60 minus 3y plus 4y is equal to 72. Solving further, so we get 60 plus y is equal to 72. So 60 plus y is equal to 72, or y is equal to 72 minus 60. So y is equal to 12. So y is equal to 12. The value of x will be, plug y is equal to 12 in this equation. In equation second, so x will be equal to 20 minus the value of y, which is 12. So x will be equal to 8. So the coordinate of this point is, so x is equal to 8. So we have 8 comma y is equal to 12. Now we need to check all the points and to be sure which among these maximizes our objective function. Okay, so for that, what will we do? So we have our objective function z is equal to 4 times x plus 5 times y. Now we need to find out the optimal points. By optimal points or optimal solution, what we mean, it is a point within the feasible region. So optimal point will be within the feasible region, that will be at any of these corners that yields the best result for the problem's objective. Okay, so what is our best result? We should get the maximum value. If we have minimum value, then our best result would have been the minimum value. Now we check at point A, where we have the coordinates says 0 and 18, and we plug the values into the objective function. So we have 4, value of x is 0, plus 5 times the value of x, y is 18. So here this is 0, so 5 8s are 40, 5 1s are 5, 6 7 8 9. So at point A we get the value of z equal to 90. Similarly, we need to check at point B. So let us see what are the coordinates of B. That are 20 and 0. Now plug here the values. So we have 4. I don't need to write. So I am just solving for z is equal to so 4 into 20 plus 0, rather 5 into 0. Here we get 4 20s are 80, 5 zeros are 0, so we get 80. Now we need to check at point C. So at point C we have 18 and 12. So what will be the value of z? Let us find out. So 4 times the value of x is 18, plus 5 times the value of z is 12. So it becomes 4 8s are 32, 4 1s are 4, 5 6 7. So 72 plus 5 12s are 60. So we get here 0. So rather 2 so we get 132. Sorry, here we have only 8. Sorry for this. So we have 8 here, so that means we have 8 here. So 4 8s are 32, plus 5 12s are 60, so which gives us 92. Here you can see among the feasible points, our optimal point will be that very point which maximizes our objective function. So this point C maximizes because 92 is the greatest among the given feasible points when we maximize it and put the values into the objective function. That means when x is equal to 8 and y is equal to 12, our objective function is maximized, and maximum value that we got here is 92. Okay, so solve the linear programming problem using graphical method, and we will take the case where we have the multiple solutions. Okay, so in the earlier video we got a unique solution. So let us say we have a question that is we want to maximize our objective function, that is z is equal to 5x1 plus 10x2, and we have the constraints here, that is x1 plus 2x2 is less or equal to 120, x1 plus x2 is greater or equal to 60, x1 minus 2x2 is greater or equal to 0, and we have the non-negative restrictions, that is x1 and x2 are greater or equal to 0. So first thing is what we do, we take these constraints and draw them on the graph. Okay, so to solve them, what will we do? Simply for the first equations, we have x1 plus 2x2, we set it first equal to 0, then we solve. Okay, so here you can see for x1 and x2 what will we get the values when x1 is equal to, so here we have rather 120, sorry, so we remove the inequality to find out the coordinates on the graph. Okay, so when x1 is equal to 0, that means 2x2 is equal to 120, which means x2 is equal to 60. Okay, so when x1 is equal to 0, x2 is equal to 60. Similarly, when x2 is equal to 0, so this term is equal to 0, that means x1 will be equal to 120. So when x2 is equal to 0, here we will get 120 for the first constraint. Okay, so we have x1 is 120, so let me show it here. Let us say this point denotes 120, and our x1, here you can see, rather our x1 is 120 and x2 is 60. Let us say this point is 60. We draw these 2 pointers, rather we join these 2 pointers, we get the graph for x1 plus 2x2 is equal to 120. Next thing is we take the second constraint and set it equal to 0, that is x1 plus x2 is equal to 60, and we draw the pointers, that is we have x1, x2. So when x1 is equal to 0, in this equation x2 will be equal to 60, and when x2 is equal to 0, x1 will be 60. Okay, so we have 60 on x1, so let us say this point is 60, and x2 which is also 60 here again, then we join these two like this, we get the graph for this very equation. Next we have x1 minus 2x2, so we have x1 minus, rather let me use another color, x1 minus 2x2 is equal to 0, which means x1 is equal to 2x2. Okay, so what are the pointers here for x1 and x2? Let us see. So let us take x1 and x2. So when x1 is equal to 0, x2 will be equal to 0. Similarly, let us take some pointers here. Let us say when x2 is equal to 5, if x2 is equal to 5, that means x1 will be equal to 5 into 2, which is equal to 10. Similarly, when x2 is equal to 10, x1 will be twice, rather when x2 is equal to 10, x1 will be 2 into 10, which is 20. Okay, so we will get multiple, we will get this kind of line, and let me try to draw it like this. Okay, now we need to find out the feasible region, the common what is feasible region? The area, what we call the feasible region, the area that satisfies all the constraints of the problem, that is our objective function. Rather we call that very area as feasible area, okay, or feasible region. Simply the area that satisfies all the constraints of the objective function, we call that very area is the feasible area. Now in the first case we have x1 plus 2x2. Since we have this inequality sign, okay, we have less or equal to 0, less or, so let me put it simple thing. When we have this less or equal to sign, this sign, and we have, let us say, this very line, now it is shaded part, we shade the area below, okay, so in this direction we shade the area. If we have again, if we have another line, let us say again this line, and in this case if we have greater or equal to sign, our shaded area will be this very area, okay, we shade the upper region. Now let us see what happened here. So x1 plus 2x2 is less or equal to this very thing. So this is our equation. So we shade the below area, this area. In the second we have x1 plus x2 greater than 0. So x1 plus x2 rather greater or equal to 60. So we have to shade the above area, that means this area. In the third one, let us see. So can we write x1 is greater or equal to 2x2. So in this case, if this is the case, then the shaded area will be this area. Now we need to find out the common area. Okay, the feasible region is the area that satisfies all the constraints. Here you can see, so common area will be this very quadrilateral. Okay, so this will be our feasible region. Here you can see all the constraints are satisfied, because for the red line we share this portion, for the black line this region, and for the green line this region. So this will be our feasible region. Okay, this is our feasible region. Now we need to find out the coordinates, and let us write the coordinates. What were the coordinates here? So let us say this is point, let us say this is our point. So for this it was here 60. So let us say we have this is point A, this is point B, this is point C, and this is point D. For A we have the coordinate says 60, 0. For B we have 120, 0. So our optimal solution will lie, rather our optimal solution will be either at this point, this point, this point, or this, because this is the shaded region. So the line is joining the shaded region, denote the set of pointers that are the feasible solutions here. Okay, so and we need to find out which of these is actually the feasible solution. So we have the coordinates of A, B, but we need to find out the coordinates of C. To find out the coordinates of C, what will we do? Since x1 is equal to 2x2, we plug the value of this in this equation to find. So we have this line, this line corresponds to x1 plus 2x2 is equal to 120. So we take this equation rather and this equation. So these two intersect at this point. We solve these two, that is x1 plus 2x2 is equal to 120 and x1 is equal to 2x2 to find out the coordinates of point C. So x1 is equal to 2x2, plug it in this equation, so we get 2x2 plus 2x2 is equal to 120, or 4x2 is equal to 120, dividing both sides by 4, x2 will be equal to 30. that means x1 will be equal to 60. So the coordinates of point C are 60 and 30. What about the coordinates of point D? So we have the red line corresponds to x1 plus x2 is equal to 60, and we have this green line, it corresponds to x1 is equal to 2x2. Solving this, plug the value of x is equal to 2x2 in this equation, so we get 2x2 plus x2 is equal to 60, or 3x2 is equal to 60, or x2 will be equal to 60 upon 3, which is 20. That means x1 will be equal to 2 into 20 is 40. So the coordinates are 40, 20. So here we have the coordinates is for 40, 20. This point does not correspond, this point doesn't represent our feasible point because it is outside the feasible region. Okay, so we have these 4 points which are our feasible points here. Okay, now let me rub this out. Now we need to find out the optimal solution if it exists in this equation. Okay, so for we have the maximization problem, z is equal to 5x1 plus 10x2. We evaluate the objective function at each of these points to see whether we have one unique solution or multiple solutions. So let us take point A. At A we have the coordinates is 60 for x1, 0 for x2. That means z will be equal to 5 times 60 plus 10 times x2 is 0. So this gives us 5 6 are 30, so we get 300 here. Now let us take point B. At point B we have the coordinates is 120 comma 0, so z will be equal to 5 into 120 plus 10 into 0. So this is here 5 zeros are 0, 5 2s are 10, 5 1s are 5, which is equal to 600. So z is equal to 600 at this point. Now let us take the point C. At C we have 60, 30. So z will be equal to 5 into 60 plus 10 into 30. So here we get 5 6 is 30, so 300 plus 10 into 30 is 300. So z again comes out to be 600. So at this point z is equal to 600, rather no, at this point z is equal to 600, and at this point also z came out to be 600. And let us evaluate it at point D. So at point D, so the coordinates of D are 40 comma 20. So let us see, z will be equal to 5 into 40 plus 10 into 20. So we will get here 5 into 40, 5 4 are, which is 200 plus 200, we will get 400. So at this point z is equal to 400. Obviously you can see at point C and at point B we get z is equal to 600 and 600. So we got two optimal solutions, or we got the optimal solutions. In this case we did not got a unique solution, only one solution. Here we got two solutions. So we will solve the linear programming problem using graphical method. We will take the case of unbounded solution. So the question is, we want to maximize the objective function z is equal to 3x1 plus 2x2, and we have constraints here, that is 5x1 plus x2 is greater or equal to 10, x1 plus x2 greater or equal to 6, and x plus 4x2 greater or equal to 12. And we have these non-negative constraints, that is x1 x2 greater or equal to 0. Okay, so let us see. So let us take these one by one. So first we have 5x1 plus x2. Let us remove the inequality with equality to solve this. So let us find out. So we have x1, x2. So when x1 is equal to 0, x2 will be 10. When x2 is equal to 0, x1 will be 10 upon 5, which is 2. Okay, so we have x1, when x1 is equal to 0, x2 is equal to 10. Let us say this point denotes this 10. And when x2 is equal to 0, x2 is 2. Let us say this point is 2. This is for the first line. Let's take the another line, that is x1 plus x2. x1 plus x2 is equal to 6. Again solving by same method. So we have x1, x2. When x1 is equal to 0, x2 is 6. When x2 is equal to 0, x1 is 6. So we have 0, 6. So we have, let us say this is 6 here. Then when x2, if x1 is equal to 0, rather is when x2 is equal to 0, x1 is 6. When x1 is equal to 0, x2 is 6. Let us say this point. Then we have the third constraint, that is x1 plus 4x2 greater or equal, or let us remove it with the equality sign to solve this on the graph. So we have x1, x2. So when x1 is equal to 0, x2 will be equal to 12 upon 4, which is 3. And when x2 is equal to 0, x1 is equal to 12. Okay. So we have 0, rather we have when x1 is equal to 0, x2 is equal to 3. Let us say this point denotes this 3. And when x2 is equal to 0, x1 is 12. So let us say this point denotes 12. Can I join these? Let us find out. Okay, so this is 12. Now here you can see we have greater or equal to sign. So what is the common region? Rather our common region is this time we have a problem of unboundedness. That is, this condition applies only to the maximization problem. First thing is that because of the non-negative constraint. We have the non-negative constraints when all the constraints, in this case we have all the constraints is non-negative, that is greater or equal to some constant. Okay, so you can see for in this case what we need to do, we need for this black line we need to shade the area above. Okay, in this line also we need to shade the above area because we have greater or equal to, and in the red line also we need to shade the above area. So we will get an unbounded solution. So we get a problem of what we call the unboundedness. Okay, so in the unbounded we say feasible solution is unbounded. That is, these are the points in the feasible region with arbitrarily large z values of the objective function. Okay, so we will get infinite value of the z function. So in this case we will have what we call unbounded solution. We'll solve a linear programming problem using graphical method and take the case of no feasible solution. Okay, so we want to maximize our objective function, that is z is equal to x1 plus x2 subject to the constraints, that is x1 plus x2 or less or equal to 1, x1 plus x2 are greater or equal to 3, and we have this non-negative restriction, that is x1 and x2 are greater or equal to 0. Okay, so let us first draw the graph here. So we have x1 and x2. So since we have x1 plus x2, x1 plus x2, to draw the graph we take equality sign here. Okay, so you can see here we have x1 and x2. When x1 is equal to 0, x2 will be 1, and when x2 is equal to 0, x1 will be 1. So let us say this point is 1, this point is also 1, so we will get this region. Since we have less or equal to sign, so that means we need to share the below area. Okay, so this is one constraint. For the second constraint, we have x1 plus x2 is equal to 3, and let us take the values. So we have x1, x2. So when x1 is equal to 0, x2 is equal to 3, and when x2 is equal to 0, x1 is equal to 3. So we have, let us say this is 3 here, this is 3 here, so we have this very line. Now since we have greater or equal to sign, that means we need to shade the above region. So what is our solution? We have a no feasible solution situation. We cannot find out the feasible region for this problem, hence the problem has no solution. Now what is feasible solution? So feasible solution is the region or the area that satisfies all the constraints of the problem. Okay, so we don't get a common region of these two lines here, so we cannot get the feasible solution here, because this line goes, we share this part, and here we shared this part, so we will not get the feasible solution in this case. If I take the definition of the feasible solution, we know, if I write the definition of the feasible solution, so feasible solution is, let me write it here. Feasible solution means we say a set of real values of x, x is equal to, let us say, x1 comma x2 so on up to xn, which satisfies all the constraints. Constraints can be what we call less or equal to, or equal to, or greater or equal to, and also satisfies non-negative restrictions, that is x1 comma x2 so on xn, they should be greater or equal to 0. Okay, so in this case we don't get any feasible solution. How to find out the marginal rate of substitution for the given utility function? The question is, given the utility function, utility is a function of two goods x and y, which is equal to under root x plus y, we have to find out the marginal rate of substitution. Okay, by marginal rate of substitution, what we mean, marginal rate of substitution is a measure of how many units of good one the consumer is willing to give up in exchange for another good, and marginal rate of substitution between good x and y is being given by the marginal utility of good x upon marginal utility of good y. Okay, marginal utility of good x is the change in the total utility due to the change in the consumption of good x, divided by marginal utility of good y means the change in the utility due to the change in the units of good y consumed. Okay, it is actually equal to minus, because this rate of substitution will be negative if I consume 1 unit of good 1. I have to give up some units of good 2. That is why the relation is negative. So we will get here minus time. What is du upon dx? That is the partial derivative of the utility function with respect to x. Okay, so can I write this utility function as x plus y whole raised power 1 upon 2. Now its derivative with respect to x will be, so first we apply the power function rule, so the exponent becomes coefficient, so we have 1 upon 2, then we have x plus y, and then exponent is subtracted by 1, that is minus 1 upon 2 times the derivative of x, which is in the brackets. So derivative of x is 1, so we are applying here chain rule also, divided by, similarly du upon dy means the partial derivative of utility function, and the exponent, rather here exponent becomes coefficient and exponent is subtracted by 1, so we get here 1 upon 2 minus 1. I will explain. It will become minus 1 upon 2. Similarly, the derivative with respect to good y will be, exponent again becomes coefficient, then we have x plus y, and exponent is subtracted by 1, 1 upon 2 minus 1 times the derivative of y, which is 1. So we will get 1 upon 2, 1 upon 2 gets cancelled. We have minus here. We get x plus y raised power minus 1 upon 2 divided by x plus y raised power minus 1 upon 2. So these gets cancelled and we get marginal rate of substitution is equal to minus 1, or in absolute terms our MRS between x and y will be equal to minus 1, which is equal to 1. So we have constant marginal rate of substitution here, which is equal to 1. Now the question is, given a demand function is P into Q is equal to 60, where P is the price, Q is the quantity. If price is equal to 6 in the demand function, then the price elasticity of demand is, options are being given, we need to find out the correct option. Okay, so we have the demand function P into Q is equal to 60. This is our demand function, and we are being told P is equal to 6. Corresponding to this P is equal to 6, we need to find out the price elasticity of demand. Okay, now what is elasticity of demand formula? That is, if I write it here, price elasticity of demand, its formula, as we know from various videos that I have made, it is equal to minus times the change in the quantity demanded due to the change in the price times price upon quantity demanded at that price. Now given this demand function P into Q, let us solve this, or let us write it in this fashion. Q, we have capital here. Okay, so let us solve this equation for Q. That means Q will be equal to 60 upon P differentiated with respect to P, that is the change in the quantity demanded due to the change in the price, will be equal to, take its derivative with respect to P, it becomes minus 60 upon P square. Okay, also we are being told when P is equal to 6, what is the quantity demanded? So when P is equal to 6 in this equation, quantity demanded will be 60 upon 6, which comes out to be 10. So elasticity of demand is equal to, which is equal to minus, then we have minus dq upon dp, came out to be 60 upon P square, minus 6 square into price, which is given as 6, divided by, then we have Q, which is equal to 60 upon P. So Q is equal to 10. We know it is 10. So what will we get here? So 10 ones are 10 6 are 60. 6 into 6 is 6 square. So 6 square gets cancelled. We get price elasticity of demand equals to 1 here. How to find out the optimal consumption bundle in case of linear indifference curve? The question is, suppose that a consumer in a two commodity world has linear indifference curve with slope equals to -1 upon 2. Find out the equilibrium consumption when prices for both commodities equal to $2 and income level of the consumer is $2,000. How does the equilibrium bundle change when the price of good X is $1 and price of good Y is $4 with the same level of income? Okay, so we are being told we have the linear indifference curve. Okay, that means our utility function is linear in both the goods. Now when we have a linear indifference curve, if I draw the graph here to make things clear, let us say we have X on the horizontal axis, Y on the vertical axis. These are the two goods. Now we have a linear indifference curve and its slope is equal to -1 upon 2. Okay, let's take the absolute slope because we are interested in absolute slope. So absolute slope of the linear indifference curve is 1 upon 2. To find out the optimal bundle, first let us see what also we are being given in the first scenario, that is price of good X is equal to $2, price of good Y is also being given us as $2, and income of the consumer is 2,000. Okay, let's construct the budget constraint, that is price of good X times units of good X plus price of good Y times units of good Y should be equal to the income of the consumer. So we have 2x plus 2y is equal to 2000. Dividing both sides by 2, we get here x plus y is equal to 1000. What is the endeavor of the consumer? Consumer wants to maximize utility here. But we don't have the utility function, but we have the slope of the utility function. Now we know that slope of the utility function is simply the marginal rate of substitution between good X and Y, which is equal to the marginal utility of good X upon marginal utility of good Y, and it is equal to 1 upon 2. Okay, the slope of the indifference curve is actually our marginal rate of substitution, or our marginal rate of substitution is actually the slope of the indifference curve. With the linear utility function, with the linear indifference curve, how do we achieve the optimality? We compare the slope of the indifference curve. Okay, so 1 upon 2 denotes the slope of indifference curve, and we equate the slope of the indifference curve with the slope of the budget line. And what is our budget line? What is the slope of the budget line? Slope of budget line, as we know, is the ratio of the prices, price of good X upon price of good Y, which is equal to $2 upon $2, which is equal to 1. Okay, so let us first draw the budget line. Its slope is 1. So let us say here we have 1, here also we have 1. So let us draw, this is our budget line. Now with the given budget line in the maximization problem, what is the endeavor of the consumer? He wants us to achieve the maximum satisfaction. That is, his endeavor is to reach to the highest possible indifference curve. The slope of the indifference curve is 1 upon 2. Okay, so the slope of the indifference curve is flatter compared to the slope of the budget line. Here we have 1, here we have 1 upon 2. Okay, that means this budget line is steeper than the indifference curve. So one indifference curve can be this, So another indifference curve will be like this. So we want to reach to the highest possible indifference curve, so we will get like this. IC, let us say this is IC1, IC2, IC3, IC4. Okay, here you can see IC1, 2 and 3. These will not give us the optimality here because we are not getting the optimal solution in the 3 ICs. So optimal solution will lie at a point where the indifference curve and the budget line intersect with each other at one point. So here they intersect, here they cross each other. They will not give us the optimal point. So optimal point will be at a point where the indifference curve and the budget line touch each other. Okay, so what happens at this point? Since the indifference curve is flatter than the budget line, that means our optimal bundle will be that consumer consumes 0 units of good X and all units of good Y. Okay, that means X is equal to 0. Now we plug X is equal to 0 in this equation. That means when X is equal to 0, so Y will be equal to 1000. That means consumer will consume all units of good Y and 0 units of good X in this case, and we get the corner solution in the first scenario. Now in the second scenario, what we are being told, let me rub this and draw it again. Again we have X and Y. In this case we are being told that the price of good X is 1, price of good Y is 4. Okay, so what will be the new slope? So price of X upon price of Y. Price of good X is 1, price of good Y is 4. So we get 1 upon 4, 1 upon 4. Now let us draw this budget line first and compare it with the slope of the indifference curve. Here you can see the steeper among the budget line and the indifference curve is obviously the indifference curve. So budget line is steeper comparatively. So let us draw the budget line this time. So this is, let us say this is our budget line. Okay, budget line. This time our what we call the indifference curve is steeper. So we will have 1 upon 2. So we will have, this will be, okay, let me draw it like this, 1 upon 2, then we will have another. Okay, I am not able to draw it perfectly, but you can see here this line is steeper than the budget line. Since this is the indifference curve, so it touches the budget line at x-axis this time because it is steeper than the budget line. In this case, what will happen? Consumer will consume all units of good X and 0 units of good Y. Okay, in the second scenario, Y will be equal to 0. So if Y is equal to 0, plug it into the budget equation. So we have X plus 0 is equal to 2000, which gives us X will be equal to 2000, rather 1000. No. Our budget line this time is, we have this very budget line where the price of good X is 1 and price of good X is 4. Okay, so here X consumer will consume 0 units of good Y and all units of good X. We plug here the value. Okay, so in this budget line this time, since Y is equal to 0 in the budget line, so we have X plus 0 is equal to 2000. In this case, X will be equal to 2000 and y will be equal to 0. So in the first scenario our optimal bundle was 0, 1000, and in the second scenario we have 2000 and 0. How the equilibrium price changes when there is change in the intercept of the supply curve. The question is, in a market model for commodity, quantity demanded is equal to A minus BP. P denotes the price. Quantity supplied, which is QS, is equal to minus C plus DP, where P denotes the price. A, B, C, D are all greater than 0. We need to find out how will the equilibrium price change when the intercept of the supply curve changes. Okay, so we know that if I draw the graph here, so we have quantity on the horizontal axis, price on the vertical axis. Okay, so we have the supply curve and demand curve here. We know that at equilibrium quantity demanded should be equal to the quantity supplied. Let us solve it here. That means A minus BP should be equal to minus C plus DP. Okay, which gives us A plus C is equal to DP transpose, it becomes plus BP. Or can I write it like this? A plus C is equal to, let us take P common, we are left with D plus B, or P is equal to A plus C divided by D plus B. Okay, this is our equilibrium price. So if we have quantity demanded like this and we have quantity supplied like this, so it is supply function, it is our demand function, equilibrium occurred at this point. But we need to find out how will the equilibrium price change when the intercept of the supply curve changes. Now what is the intercept of the supply curve? So this is the intercept of the supply curve. Okay, C denotes the intercept of the supply curve. So we need to find out, since equilibrium price is this, so the change in the equilibrium price due to the change in the intercept means the partial derivative of the price function with respect to the intercept of the supply function. We need to differentiate it with respect to C. Derivative of a constant is 1, derivative of C will be 1, so we have 1 upon D plus B. This will be our the change in the change in the equilibrium price. Okay, it can mean that intercept, if it was here, so it can shift like this. Our equilibrium price could be this 1 divided by, or the change in the what we call the equilibrium price occurs, that is, this is the change in the equilibrium price, and this is equal to this this term, or the supply curve can move or shift towards right. So in both the cases, when this intercept changes, our equilibrium price will change according to this condition. We will learn how will the equilibrium price change when the slope of the supply curve changes. The question is, in a market model for a commodity, quantity demanded is equal to A minus BP, quantity supplied is equal to minus C plus DP, A, B, C, D are greater than 0. We need to find out how will the equilibrium price change when the slope of the supply curve changes. Okay, at equilibrium we know that at equilibrium what happens, quantity demanded is equal to the quantity supplied. Quantity demanded is A minus BP, it should be equal to quantity supplied, which is minus C plus DP. Okay, so can I write A plus C is equal to DP transpose, it becomes plus BP, or A plus C is equal to, let us take P common, we are left with D plus B, or our equilibrium price is equal to A plus C divided by D plus B, so we get D plus B. This is our equilibrium price. Graphically, if I draw a simple graph here, so we have quantity on the horizontal axis, price on the vertical axis, we have the usual downward sloping demand curve, and we have upward sloping supply curve. Okay, so initially equilibrium is achieved at this point, that is P star. Now what we are being told, how will this equilibrium price change when the slope of the supply curve changes? What is the slope of the supply curve? That is this D. Okay, so we need to find out the change in the equilibrium price due to the change in the slope. Slope is D, so we have D here. Okay, that means we partially differentiate this function with respect to D. Okay, so here we use the quotient rule. That is, first we write the denominator function, that is d plus p, then we take d upon, because d denotes the slope, dd of the numerator function a plus c, then we subtract and write the numerator function a plus c and take the derivative of the denominator function, which is d plus p, and we divided by d plus p whole square, d plus p whole square. You know this quotient rule, I don't need to make mugs and toss here. Okay, so the the change in the equilibrium price due to the change in the slope will be equal to, so we have d plus p. Now the derivative of this function with respect to d is 0, so we get here 0, minus we have a plus c. Now the derivative of this function with respect to d is 1, so we are left with 1, so we get divided by d plus p whole square. I hope I am making myself clear. So this 0 times this term is 0, so here we get minus a plus c divided by d plus p whole square. This is the change in the equilibrium price when the slope changes. So slope can change either like this or like this. In either case, either we will get this very equilibrium price as this thing, or we will get this thing. Okay, so we are not being told whether the price or rather slope increases or decreases. Okay, it only increases. I hope I made myself clear. In this video we will solve a question on probability. The question is 5 cards are drawn successively from a well shuffled pack of 52 cards with replacement. Determine the probability of getting 3 spade cards. Okay, so how do we solve this question? So let us suppose, and let me write it here, let x be the number of spade cards among the 5 cards drawn. Okay, we say x be the number of spade cards, let me write it here, among the 5 cards drawn. The cards that we draw, let us suppose x are the number of spade cards among them. Okay, since cards are drawn with the replacement, so the question is with replacement. So since cards are drawn with replacement, the trials are Bernoulli trials in this case. Okay, so we have the, and let me write it here, since the cards are drawn with replacement, the trials are Bernoulli trials. Okay, Bernoulli, Bernoulli trials. Okay, now we know that in a well shuffled pack of 52 cards there are 13 spade cards. Okay, so total number of cards in the 52 deck of cards, we have only 13 spades. Okay, so we have 13 spades out of 52 cards. Okay, therefore probability of getting a spade card is equal to the number of spade cards, that is 13, divided by total number of cards, which is 52, which is equal to 1 upon 4. Similarly, probability of not getting a spade is equal to 1 minus the probability of getting spade. So Q will be equal to 1 minus the probability of getting spade is 1 upon 4. So Q is equal to 3 upon 4. We need these two results because we have the Bernoulli trials here. Okay, So in this case X has Bernoulli distribution. Okay, and let me write it here. So in this case X has Bernoulli distribution with the number of chords. So we have n is equal to 5 here, and probability of getting a spade is 1/4, which we showed here. Okay, now probability of x is equal to small x means, that is, which implies probability of x is equal to 5, that is, or rather let me write it here. So x is equal to 1, 2 up to n, or let me first write the Bernoulli distribution here. So our probability of x is equal to small x, and we know x is from 0 to n, will be equal to n c x q raised power n minus x times p raised power x. This is the Bernoulli distribution formula. NCX means the combination of getting n spades from x spades from n chords. Okay, Q denotes the probability of not getting a spade, P denotes the probability of getting a spade. So here we have n is 5, so can we write 5 C, since we are being told that we need to get 3 spade cards, so here we have 3, Q raised power 5 minus 3, P raised power 3, which implies we get, so we can write it as 5 factorial divided by 3 factorial, then we have 5 factorial minus 3 factorial, which is 2 factorial. Okay, Q is 3/4, so 5 minus 3 is 2, and P is 1/4 cube. Solving further, that means probability, okay, here we have probability of x is equal to 3. Okay, and here x is equal to 0, 1 and so on up to n. So probability of getting 3 spades will be equal to, so can we write it like this, 5 into 4 into factorial 3, factorial 3 factorial divided by, then we have 3 factorial and times 2 factorial. 3 3s are 9, 4 4s are 16, so 9/16 into 1/4, 4 are 16, 4 are 64, which is equal to, so 3 factorial gets cancelled, we get 5 into 4 divided by, so 2 factorial is 2 into 1, then we have 9/16 into 1/64, which is equal to 5 4s are 20/2 into 9/16 into 1/64. So here it is 10, then we get 5, here we get 32, so 5 9s are 45 divided by, we have 16 into 32, so 32 into 16 is equal to 6 2s are 12, 6 3s are 18, again 19, then we have 1 2s are 2, 1 3s are 3, so we have 2, now this is ka 3 4 512. Okay, so we get 512. So probability of getting 3 spades, okay, will be equal to 45 upon 500. The question is, if the government expenditure rises by $100, total revenue rises by, that is the total tax revenue rises by $100, the value of the marginal propensity to consume is 0.5 and there is no change in the autonomous investment and consumption. In a simple Keynesian closed economy model, GDP rises by, options are being given, we need to find out the correct option. Okay, so we are being told that the change in the government expenditure is $100, tax revenue increases to $100, marginal propensity to consume is 0.5. we need to find out how much the income rises using our national income identity, that is our total income will be equal to the consumption expenditure plus investment expenditure plus government expenditure. Okay, so our income will be equal to, what is consumption, that is A plus B times Y minus the tax revenue. Okay, what what is disposable income, that is the total income minus the taxes paid on that very income. So this denotes our total taxes here. So A plus B, YD is this very term, so YD is equal to Y minus T, plus investment is autonomous and government expenditure is being given us as, rather we are not being given the government expenditure. Okay, solving it further, so we have Y is equal to A plus, so B marginal propensity to consume is 0.5. Can I write 0.5 times, or let me further explain it, so it becomes By minus Bt plus I naught plus G naught, rather G. Okay, that gives us our total income is equal to A plus, what is B? B is 0.5 Y, then we have minus B, then we have again we have minus 0.5 times T plus I naught plus G. Okay, now take differential on both sides, that means, or first let us transpose this term here, so we get Y minus 0.5 Y is equal to A plus, rather minus 0.5 T plus I naught plus G. So this sums up to 0. Rather this subtracts to 0.5 Y is equal to A minus 0.5 T plus I naught plus G naught, rather G only. Now let's take the differential on both sides. Okay, so we have 0.5, differential of Y is del Y is equal to, so since no changes in the autonomous investment, so the differential of A will be 0 minus, we have 0.5 times the change in tax, that will be del T, plus autonomous investment is also being told it is autonomous here, rather there is no change, so the change in I naught will be 0 plus, but there is change in the government expenditure, so we'll write it here del G. Okay, so we have del Y, 0.5 del Y. Okay, let me write it here. So we have 0.5 del Y is equal to minus 0.5 del T plus del G. Okay, so the change in the government expenditure, that is 100, so we can write 0.5, sorry, change in the income is to be found out. Now we have minus 0.5, the change in the tax revenue is 100, so we write del T is 100 plus change in government expenditure is 100. Okay, sorry for the mistakes that I do. So can I write 0.5 as 1 upon 2 del Y will be equal to, so minus 0.5 into 100 is minus 50 plus we have 100, so we get del y is equal to, here it is 50, transpose this, it gets multiplied, so we get the income will rise by 100. Okay, so let us see how do I take the differential here, because the change in the income, that is del y, here we are being told that change in investment is 0, so I wrote it here 0, that it is constant. Okay, similarly the change in the autonomous consumption, what is A denotes the autonomous consumption, that's why we have 0 and 0 here, and the change was only in the tax revenue and government expenditure. Okay, the question is, if marginal revenue of a firm is $10 and the price it charges per unit is $30, assuring that the firm is a profit maximizer, what is the own price elasticity of demand for the firm at that point of profit maximization? Options are being given, we need to find out the correct option. Okay, so marginal revenue of the firm is equal to $10, that's being given us. The price it charges per unit is 30, so price per unit is being given us is $30. Also we are being told that the firm is profit maximizer. Okay, we need to find out the elasticity of demand, that is price elasticity of demand for that very firm. Now we need to find out the relationship between among price, marginal revenue and elasticity for a profit maximizing firm. We use the Lerner's index. Okay, Lerner's index, or simply we know the relationship is being given us is, that is average revenue minus marginal revenue upon average revenue should be equal to minus times 1 upon the elasticity of demand. Okay, we know this relationship. Now what is average revenue? Average revenue is nothing but price, so can we write here price, here also price, so this is the relationship. Solve. Now price is 30, marginal revenue is being given us as 10, divided by 30 will be equal to minus 1 upon E, so 30 minus 10 is 20, divided by 30 is equal to minus 1 upon E. Okay, that gives us, this gets cancelled, so we have 2 upon 3, or let me rub this out now, that gives us 2 upon 3 is equal to minus 1 upon E, reciprocate both sides, so we get 3 upon 2 is equal to minus E, multiply both sides by minus 1, so we get E is equal to 3 upon 2 is minus 1.5. Okay, so price elasticity of demand will be what we call minus 1.5, so this option is correct. Next question is on the input-output model. The question is, the input-output matrix for two-sector economy is being given by us as A is equal to 0.25, 0.4, 0.1 and 0.1. This is our input-output matrix. If the external demand for the outputs of the two sectors is being given us as D is equal to 10 and 20, which is column matrix, we are supposed to find out the optimal levels of the two commodities. Okay, I will not go into the explanation what is meant by input output model. Here I will only solve the question. For that I will make a separate video what is meant by input output model and what are meant by the terms that we use in input output model. Okay, so we have the technology matrix or input output matrix, which is A is equal to 0.25, 0.1, 0.4, 0.1. Okay. Also we are being told that final demand is 10 and 20. First thing is what we do, we form the Leontief matrix. So Leontief matrix is being formed by, we write the singular matrix minus, we subtract the technology coefficient matrix, that is A. This will be our Leontief matrix. So we have 1 0 0 1. To this we subtract 0.25, 0.1, 0.4, 0.1. So we will get 1 minus 0.25 is 0.75, 0 minus, so it is minus 0.1. Here we have also minus 0.4. Here 1 minus 0.1, it is 0.9. Okay, this is our Leontief matrix. Now next step is we need to find out, or let me rub this now. Next step is, so I minus A is this. Next step will be to find out the determinant of this I minus A, which is Leontief matrix. Its determinant, as we know, we multiply these two elements first. So we have 0.75 times 0.9. To this we subtract the product of minus 0.1 times minus 0.4. So it will come out to be, when we solve this, it comes out to be this term 0.675 and this term comes out to be 0.04. It comes out to be 0.635. If it was 0, then the system was not feasible. Since it is not equal to 0, so we have the determinant of I minus A equaling this. Next step will be to find out the inverse of this matrix. For that, first we need to find out the adjoint of this matrix. So adjoint of Leontief matrix, that is I minus A. So how do we form adjoint in case of 2 cross 2 matrices? What we do, we interchange the elements that are on the principal diagonal, okay, and we change the sign of the non-principal diagonal elements, okay. So here we will get, so this 0.9 comes here, this 0.75 comes here. In this direction we only change the sign. If it is minus 0.4, it becomes plus 0.4. So if it is minus 0.1, it becomes 0.1. Okay. Now next is we need to find out the inverse, that is the inverse of I minus A matrix. So inverse is simply 1 divided by the determinant of the Leontief matrix I minus A times adjoint of I minus A. Okay. So can we write it like this? So determinant is 1 divided by 0.635 times this 0.9, 0.4, 0.1, 0.75. Okay. Now let me rub this out. So our I minus A inverse will be equal to, so dividing 0.9, 0.4, 0.1, 0.75 individually by 0.635, what will we get? We will get 1.42, 0.63, 1.16 and 1.18. Okay. Then to find out the optimal levels of output, so we use the formula, that is x, which is equal to x1 x2 is equal to, that is the inverse of I minus A Leontief matrix times the final demand. So final demand is D So can we write it like this? D is being given us as 10 and 20, 10 and 20. So our x, which is x1, x2, will be equal to, so we have this matrix, that is 1.42, 1.16, then we have 0.63, then we have 1.18. To this we multiply 10, 20. So multiplying, so we have matrix multiplication here. Since that these two matrices are conformable, that is matrix multiplication is defined. Why? Because the number of columns in the first matrix is equal to the number of rows in the second matrix, so we can do the multiplication here. So multiplying this with this, row with column, so we get 1.42 times 10 plus 0.63 times 20. And what will be the order of the new matrix? So here we have 2 into 2, 2 into 2, here we have 2 into 1. So the order of new matrix will be 2 into 1. So we will have 2 rows and 1 column. So we need to write here next multiplication, that is 1.16 into this. So 1.16 into 10 plus 1.18 into 20. Doing this, what we will get? So our x, that is x is equal to x1, x2, it comes out to be, so here it becomes 14 point, I have done the calculation, 14.2 plus 12.6, this sums up to 11.6 plus 23.6, so we will get, adding them, 26.8 and 35.2. Okay, so this should be the value of optimal, at optimal, okay, value of x1 and x2, that is the value of the optimal levels of the two commodities. The question is how to find out whether a particular equation is unidentified, just identified, or over-identified. The question is, consider the following system of equations. We have three simultaneous, we have the three equations. Y1 is equal to alpha naught plus alpha 1, y2 plus alpha 3, y3 plus alpha 4, x1 plus alpha 5, x2 plus u1. Okay, so u1, u2 and u3, these are the residual terms, alpha naught, beta naught and lambda naught. These are the constants. Okay, so how do we find out the order condition for identified, exactly identified, or under identified? For that we use the order condition. Okay, so for order condition, what we use the order condition? Order condition tells us, and let me write it here. Let me denote some variables here. Let us say k. What is k? Or let me write it here, k minus m, and we have another g minus 1. Now let me explain all these terms. What is meant by k? This k denotes the total number of equations. This k denotes the total number of variables, whether they are endogenous or exogenous, in our model. M denotes the number of variables in a particular equation. G denotes the total number of equations in the model. Okay? Now, if we get it, the equality sign, then we have exactly what we call identified. The particular equation is exactly and what we call identified if this equality sign holds. If we have k minus m, if it is less than g minus 1, in this case we say the particular equation is unidentified. similarly, if k minus m is greater than g minus 1, in this case we have our identifier. The particular equation is our identifier. Okay, now we are being told about the first equation. Okay, what will be the first equation? In the first equation, so what does k denote? K denote the total number of variables, whether they are endogenous or exogenous. Exogenous variables, as you know, they are determined outside the model, and endogenous variables are determined inside the model. So in particular, in the first equation, what will be the value of k? Rather, the value of k will be the total number of variables in the model. So we have y1, y2, y3, and then we have x1, x2, and I guess x3 is also somewhere. Okay, we have x3, x2, x1, and we have y1, y2, and y3. I guess total number of variables, whether they are endogenous or exogenous, or 6. These alpha naught, beta naught, gamma naught, these are not, these are the constants, and u1, u2, u3, these are the residual terms. They are not neither endogenous nor exogenous. Okay, so total number of variables in the equation, rather in the model, that is the value of k. K is, so k comes out to be 6 minus what is m? M denotes the number of variables in a particular equation. Since we are being told about the first equation, what are the variables here? y1, y2, y3, x1, and x2. So we have 1, 2, 3, 4, 5. So m will be 5. Now g, total number of equations is 1, 2, and 3. Let's write it here, 3. Okay, now 6 minus 1. 6 minus 1 is, 6 minus 5 is 1, and 3 minus 1 is 2. So this inequality holds. Okay, so that means first equation is unidentified. Okay, so the correct option should be A option here. Now here we can also see what about, so the question was only about the first equation. Let us say we are being told about the second equation. So what will happen in the second equation? So total number of variables in our model are 6, and total number of variables in the second equation are 1, 2, 3, 4. So in this case we will have 4. So let us write it here, 4. So here first we have 6, and m denotes the number of equations in a number of variables in a particular equation, which is 4. So 6 minus 4. Here we have g minus 1. So we have 3 minus 1. In the second equation, 6 minus 4 is 2. 3 minus 1 is 2. So the second equation is just identified or exactly identified. What about third equation? So in the third equation we have 1, 2, 3, 4. Again we have 4 variables in third equation. So we will have 6 minus 4, and here we have 3 minus 1. So we get 2 is equal to 2. So the third equation is also just identified. The question is to find out the elasticity of substitution of the constant elasticity substitution production function. The question is given the CS production function is y is equal to a1 x1 raised power p plus a2 times x2 raised power p whole raised power p, where x1 and x2 are the two factors of production, y denotes the output. We need to find out the elasticity of substitution. What is the formula for elasticity of substitution? Let me write it here. So elasticity of substitution is simply equal to the change in the input ratio, that is the factors of production x2 upon x1, divided by the change in the input price ratio, the prices of x1 and x2, times P1 upon P2, like we use the elasticity formula, divided by the input ratio x2 upon x1. Okay, this is the formula. How do we get this x2 upon x1? First, we know that for optimization, what we do, we equate the marginal rate of technical substitution between x1 and x2. It should be equal to input price ratio P1 upon P2. We know this very thing. Now MRTS, as we know, it is simply, so MRTS, as we know, it is marginal product of input 1 upon marginal product of input 2. It should be equal to P1 upon P2. Okay. Now what is MP1 upon MP2? It implies the partial derivative of production function with respect to x1. Similarly, MP2 means the partial derivative of production function with respect to x2. It should be equal to P1 upon P2. We know this thing also. So let us find out this derivative. Dy upon dx1 means the derivative of this function with respect to x1 first. So we use the power function rule. Exponent becomes coefficient. So we have p times a1 x1 raised power p plus a2 x2 raised power p whole raised power p minus 1 times, we apply the chain rule, times the product of the derivative of x1. That is, what is the derivative of x1? So p becomes coefficient, so we will get p a1 x1 raised power p minus 1 divided by the partial derivative with respect to x2. Again, exponent becomes coefficient, so we have this p a1 x1 raised power p plus a2 x2 raised power p whole raised power p minus 1 times, you applying chain rule, the derivative of x2 raised power p, so p becomes coefficient, then we have a2, then we have x2 raised power p minus 1. Okay, here this term gets cancelled, p and p gets cancelled, so we are left with a1 upon a2 whole raised power x1 upon x2 raised power p minus 1. If I reciprocate it, so it should be equal to input price ratio P1 upon P2. So can I write it like this? A1 upon A2, x2 upon x1. If I reciprocate, it will become 1 minus P. Simple thing, reciprocating the terms changes the exponent sign. Should be equal to P1 upon P2, which implies, let us solve for x2 upon x1. So x2 upon x1 whole raised power 1 minus p will be equal to, transpose this, it becomes a2 upon a1 times p1 upon p2, or x2 upon x1 whole raised power 1 minus p comes out to be a2 upon a1, transpose exponent, it becomes 1 divided by 1 minus p times p1 upon p2 whole raised power 1 divided by 1 minus p. Okay, I have transposed it this, so it will not remain here. Now let me rub this out. So we got this result, and let me write it here. X2 upon x1 came out to be a2 upon a1 whole raised power 1 divided by 1 minus p times p1 upon p2 whole raised power 1 divided by 1 minus p. Now using the elasticity formula, so we need to find out the change in the input ratio due to the change in the input price ratio times input price ratio divided by input ratio. So the derivative, let us differentiate this with respect to p1 upon p2. That means the derivative of x2 upon x1 with respect to the input price ratio, that is p1 upon p2. We need to differentiate this with respect to p1 upon p2. Again, the exponent becomes coefficient, so we have 1 divided by 1 minus p, or this p1 upon p2, it becomes coefficient a2 upon a1 raised power 1 divided by 1 minus p times p1 upon p2 and its exponent is subtracted by 1. So it becomes, so we have 1 divided by 1 minus p minus 1. So it becomes 1 minus 1, minus into minus is plus p. So minus 1 gets, minus 1 plus 1 gets cancelled. We get p divided by 1 minus p here. P divided by 1 minus p. Okay. Now use the elasticity formula. So dx2 upon x1 divided by d p1 upon p2 came out to be this term, that is 1 divided by 1 minus p a2 divided by a1 whole raised power 1 divided by 1 minus p p1 upon p2 whole raised power p divided by 1 minus p. To this we multiply p1 upon p2, p1 upon p2, and we divided by x2 upon x1. x2 upon x1 is this term, so let's write it again. So we have a2 divided by a1 whole raised power 1 divided by 1 minus p times p1 upon p2 okay. So it is here 1 divided by 1 minus p. So elasticity of substitution will be equal to a2 upon a1. This gets cancelled first. Okay. Then first we have 1 divided by 1 minus p. Then we have this p1 upon p2 whole raised power p divided by 1 minus p. Then we have this term p1 upon p2. Let's raise it to the power 1. If I transpose, the exponent sign changes, so we have p1 upon p2. If it is 1 divided by 1 minus p, it becomes minus 1 divided by 1 minus p. Or elasticity of substitution will be 1 divided by 1 minus p. So here we have p1 upon p2 whole raised power p divided by 1 minus p. So bases are same, we can add the exponents here, so we get 1 minus, so we have 1 minus 1 divided by 1 minus p, so we get here 1 minus p minus 1, so this gets cancelled, so we get p1 upon p2 whole raised power minus p divided by 1 minus p. Okay, so again we have 1 divided by 1 minus p, again adding the exponent, so we have p1 upon p2 whole raised power p divided by 1 minus p. To this we add this minus p divided by 1 minus p, so this gets cancelled, so it becomes 0. So we have 1 divided by 1 minus p times, so p1 upon p2, so p1 upon p2 raised power 0, so we get elasticity equal to 1 divided by 1 minus p. Anything raised power 0 is 1 times 1, so elasticity of substitution will be equal to 1 divided by 1 minus p. I have explained how to derive it here. The question is, 6 number of dice are simultaneously rolled. What is the probability that each face shows up with different numbers? Options are being given. We need to find out the correct option. Okay, so since we have the 6 dice being thrown simultaneously, then the total sample space will be equal to the number of dice, that is the number of faces in each die, that is we have 6 in first, we multiply them 6 times 1 2 3 4 5 and 6, so it will be equal to 6 raised power 6. This is our total sample space. Now we have to find out the probability that each face shows up with different number. Okay, so let us say we have 1 2 3 4 5 and 6 dice. Okay, so since the numbers should be different, let us say 1 2 3 4 5 6, this can be one combination. Similarly rather this can be one order, another order can be 6, 5, 4, 3, 2, 1. Okay, so we need to find out different orders. For that we use simple the factorial. Factorial gives us the number of different orders that we can get. Okay, that means our probability will be equal to 6 factorial divided by 6 raised power 6, or we can write it like this: 6 into 5 into 4 into 3 into 2 into 1 divided by 6 raised power 6. Since the answer is in this format, so this option is correct. Next question is, given the matrix A is equal to 2, 0, 4, 1, 3, 1, and we have another matrix B is equal to 4, 5, 0, which of the following is or true? Options are being given. We need to find out the correct options or option. So we have the matrix A is, we have 2, 0, 4, 1, 3, 1 as the elements in the matrix A. In the matrix B, we have the element is 4, 5, 0. Let us see the first option. First option says the product of A times the transpose of B is 8, 19. That is, we have the column matrix with elements 8 and 9. Let us check the first one. So in the first one, so A is this. So can I write A B transpose is equal to, so we have 2, 0, 4, 1, 3, 1. Now what is the transpose of B? So by transpose of a matrix we mean when we interchange column with row or row with column, we get a transpose. So if these are here rows, okay, row matrix, it becomes column matrix. So we have 4, 5, 0. Interchanging rows with columns or columns with rows gives us the transpose. Now the product of these two, first we need to see whether the product is defined or not. Okay, so for two matrices, rather for two matrices, the product is defined if the two matrices are conformable for multiplication. Okay, so by conformability, what we mean? By conformability, we mean that the number of columns in the first matrix should be equal to the number of rows in the second matrix. Or we say A and B transpose, the product is defined or exists when the number of columns in the first matrix is equal to the number of rows in the second element. In the second matrix. So what are the number of columns? 1, 2, 3. And what are the number of rows in the second? 1, 2, 3. Okay. So the order is here. We have 2 by 3. And here we have 1, 2, 3, 3 by 1. Okay. Since the number of columns is equal to the number of rows, the two matrices are conformable for multiplication. So we can do multiplication. And what will be the order of the product of the matrix? That will be equal to 2 into 1. So we will get 2 into 1. That means we will have 2 rows and 1 column. So let's do the multiplication. How do we do the multiplication? We multiply rows with the columns. So this row is to be multiplied with this column. So we get 2 into 4 plus 0 into 5, 0 into 5, plus 4 into 0. Similarly, we get, then we multiply this row with this column. So we have 1 into 4 plus, then we have 3 into 5 plus, then we have 1 into 0. Here you can see, and if I write it here, so we get 2 4s are 8. So this is 0, this is 0. So we get 8 here. Here 4 1s are 4, 5 3s are 15, 15 plus 4 is 19, and it is here 0. So we get 19. Now let us see the order of this matrix. So we have 2 rows and 1 column. So 2 into 1 is the order of this very matrix. That means option A times the product of the transpose of B is equal to 8 upon 19. This option seems correct. Now let us check the another, because here the multiple options can be true. So first one is true. Let us go for the second option. Second says as A B transpose is defined. As I have told you earlier that since A times BT, that is the product of A and the transpose of B, the product of these two matrices is conformable. If it is conformable, that means the product is defined. Okay, earlier we saw that we can do the multiplication with A times the transpose of B. So this option is also correct, because AB is defined if the product is conformable. Conformable means simply if the number of columns in first matrix is equal to number of rows in second matrix. Okay, I will not repeat it. So if the product is we say two matrices are conformable if they are conformable for multiplication. When this condition happens, if they are conformable, that means they are defined. Since we saw in the earlier option the product came out to be 8 upon 19, so it is defined. Let us see the third option. So we have B times A. So first we write 4 5 0 and we multiply it with A is 204 131. Here, for the two matrices to be conformable for multiplication, what is the condition? Number of columns in the first matrix should be equal to the number of rows in the second matrix. We have 1 2 3, we have 3 columns here, but we have only 2 rows here. Okay, so they are not conformable, that means they are not, the product is not defined. So this option is incorrect. Now let us see the last one. Last one says B times A transpose. B times A transpose. Okay, so B is this 4 5 0. This is our matrix, and the transpose of A, interchanging rows with columns. So we have 204 204 column, then we have 1 3 1. Okay, this is A transpose. Let us see the conformability. Number of columns in the first matrix are 3 and number of columns in the second matrix are 3. That means we can do the multiplication, and the order is here 1 into 3, and here 1 2 3 into 2 3 into 2. Okay, so the order of the new matrix will be 1 into 2. That means we will have 1 row and 2 columns. So let us do the multiplication. So we multiply row by column, so we get 4 into 2 plus 5 into 0 plus 0 into 4. Okay, so 1 row, then we have 2 columns. So this is 1, another will be here then, because we have 2 columns. So this is 1 number, we will have another here. So now we have 4 into 1 is 4 into 1 plus 5 into 3 plus 0 into 1. 0 into 1. Okay, let me write it here. Plus 0 into 1. And this will be our matrix. So this is 4 2s are 8. This is 0. This is 0. Here we get 5 3s are 15 plus 4 is 19. So we get 19. Here you can see the order is 1 into 2, 1 row and 2 columns. So this option is also correct. So we have 1 2 and 3. I don't see if there was another option, so I guess E option was also, I didn't write it here and I don't know this time.
Next question is, given the objective function y is equal to f of x1 x2 up to xn and constant g of x1 x2 up to xn is equal to 0, the second order condition for extremum is we need to find out. So what is extremum? Either we should get a relative minimum, or relative maximum. Okay, now what are the conditions? If H2 which is second ordered bordered principle, if its determinant is less than 0, and similarly H3 if it is also less than 0, so on up to Hn nth ordered bordered principal minor, if all are less than 0, we get a positive definite matrix, and positive definite matrix satisfies the sufficient condition for relative minimum. On the other hand, if the second ordered border principle, that is H2, if the first is greater than 0, if second, that is H3, if its determinant is less than 0, that means if the bordered principal minors determinant alternate their signs from positive to negative, we get a condition of negative definite matrix, and it satisfies the condition for relative maximum. Okay, let us see in the options what we are being given. So we have H2 less than 0, H3 less than 0. So it says it is a maximum. No, it is not maximum. So this option is incorrect. In the second, H2 greater than 0, H3 less than 0. This satisfies the condition for maximum. This is correct. Now C option, H2 less than 0, H3 greater than 0. So I have told you for relative maximum, our second bordered principal minor should be greater than 0. Since it is less than 0, so this does not satisfy any condition whether for the relative maximum or minimum. What about D? H2 less than 0, H3 less than 0. This satisfies the condition for minimum. This is correct. And what about the last option? H2 less than 0, H3 less than 0. It also satisfies the condition for minimum. So this is also correct. So we have B, D and E. But we don't have here. We have only A and D, C and E, B and D, and B and E. Okay, so I guess there is some problem in the question. So here B and D, it is also correct. B and E, it is also correct. Okay, so it seems there is problem in the question. Next question is, arrange the following events in increasing order of their probability of happening. Okay, so first is probability of getting two heads in a simultaneous toss of two coins. Okay, since we have two coins, so if we simultaneously toss them, so our space will be either we will get head on both, head on first, tail on second, or head on first, or we get tail and tail. So in this case, so favorable event is HH, that is 1 divided by total number of events is 1, 2, 3, 4. So we get 1 upon 4. So here we have 1 upon 4 for the first one. Now in the second one, we have to find out the probability of getting a queen from a single draw of a card from a well shuffled pack of cards. Okay, so number of queens in a deck of cards are 4. So favorable outcomes are 4, and total number of cards is what we call 52, I guess. So it is equal to 1 upon 13. Okay, so for the second we have 1 upon 13, 1 upon 13. In the third one, we have the probability of getting white ball from a bag containing 3 white balls and 7 black balls. So number of favorable cases are here, since we have to find out the probability of white ball. So we have 3 white balls, that is the favorable cases, divided by the total number of cases, that is we have 3 plus 7, which is 10. So we get 3 upon 10 here, 3 upon 10. So for the third one, we have 3 upon 10. For the last one, probability of getting an even number from single roll of failed dice. Okay, so how many even numbers are on a die? Six sided faced die. So we have 2, 4 and 6. That means we have 3, that is favorable events divided by the total number of events are we have 6. We know that there are 6 faces, so divided by total number of events, that is 6, rather the sample space, which is 1 upon 2. So for last one we will have 1 upon 2. Now let us write them in ascending order. So lowest among all is 1 upon 13, 1 upon 13. So 1 upon 13 is for queen. That means first we should get B. Okay, so first we should get either this. Then we have 1 upon 4, 3 upon 10. So 3 upon 10 is less than 1 upon 4. So 3 upon 10 is for C. So we get C, B, C. A is 1 upon 4. Then we will get 1 upon 4. And lastly we get 1 upon 2, which is D. So the correct option should be third option if I write them in ascending order of the probability of happening. Next question is, when CIG stand for consumption expenditure, investment expenditure and government expenditure respectively on domestically produced goods and services, and X and M stand for aggregate values of export and import for a country respectively, GDP is calculated as, options are being given, we need to find out the correct option. Okay, so what is the GDP equation? So GDP equation is equal to the consumption expenditure plus investment expenditure plus government spending, that is government expenditure, plus net exports. What is net exports? That is NX. Okay, the value of NX is export minus import. Okay, so the correct option in this case should be option 1, that is this equation denotes our GDP equation. We were given the prisoner's dilemma games here. That is, we have the payoff matrix for two firms, firm 1 and firm 2. Their payoff matrix are being given us. That is, the first number in each cell denote the payoff of firm 1 when he chooses a specific strategy. Similarly, the second number in each cell denotes the payoff for firm 2 when he chooses a specific strategy. What are the strategies here? Two strategies. Firm 1 has two options, either to not to invest or invest. Firm 2 has also two options, that is not invest or no investment or investment. Okay, we are being told that if both firms choose investment, that means investment by both firms, options are is an equilibrium, is a partial equilibrium, is not an equilibrium, is a Nash equilibrium. Okay, what happens, what kind of equilibrium is when both the firms choose investment? Okay, so if firm 1 chooses investment, firm 2 chooses investment, so we have to see whether this cell is actually the Nash equilibrium or not. Okay, by Nash equilibrium what we mean? Nash equilibrium in a game theory is a situation where all participants in a game have chosen the best strategy they can given the strategies of the other players. Okay, if I write it, that will make more sense. Okay, so Nash equilibrium is a situation where all participants in a game have chosen the best strategy they can given 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 the strategies of other players of
other players. What we mean by this? Simply, that is the optimal strategy chosen by one player given other player has also chosen his optimal strategy. That gives us a kind of what we call an equilibrium, and then we call that very equilibrium as Nash equilibrium. Okay, so let us first see what exactly is the Nash equilibrium. We have here two questions. I have skipped the other two questions. So first let me concentrate on these two. So first question is investment by both firms is an equilibrium, is a partial equilibrium, is not an equilibrium, is a Nash equilibrium. Okay, so if we get this as Nash equilibrium, that means obviously this is Nash equilibrium. If we don't get this this cell as equilibrium, then obviously it is not an equilibrium. Okay, let us see how do we find out the Nash equilibrium. So let us see from the perspective of firm 1 first, or rather from the perspective of the firm 2. Let us suppose firm 1 chooses to invest, rather chooses not to invest. Okay, if firm 1 chooses no investment, firm 2 has two options, either to choose no investment or investment. No investment gives him 200 payoff, investment gives him 100 is payoff. Obviously 200 is greater than 100, so she will choose 200. Likewise, if firm 1 chooses to investment, firm 2 again has two choices, either no investment or investment. In this case, no investment gives him 250 as payoff, investment gives him 225 as payoff. Obviously 250 is greater than 225, obviously the firm 1 will, rather firm 2 will decide no investment. Now let us see this from the perspective of firm 1 when firm chooses no investment. In this case, since firm 2 is choosing no investment, firm 1 has two options, either no investment or investment. No investment gives him 200 as payoff, investment gives him as 100. Obviously 200 is greater than, so let us underline this. Similarly, when firm 2 chooses to invest, again firm 1 has two options, either to choose no investment or investment. Obviously 250 is greater than 225, she will choose this very thing. Now why does Nash equilibrium in this payoff matrix exist? It exists where both the cells are underlined or encircled, whatever you call this. So here you can see this 200 and this 200 both are underlined. That means for this game our Nash equilibrium will be 200 and 200. Okay, that means if both firms choose no investment, they get a Nash equilibrium. Okay, so for the first question, investment chosen by both firms is an equilibrium. No, because investment chosen by both the firms would have been this very cell, because nothing is being underlined here. That means it's not an equilibrium, neither it is partial equilibrium. It is not an equilibrium. Okay, so let me see. Is a Nash equilibrium? Yes, obviously. What can we say then there? Investment, if both the firms do the investment, so it is an equilibrium. No. It is a partial equilibrium. No. Is not an equilibrium? Yes. Is a Nash equilibrium? No, because we have been told even both the firms investment. So the correct option should be 3 options. Okay, now with the same thing we got our Nash equilibrium also. The question tells us Nash equilibrium occurs when both firms earn 200, 200, 225, 225, 100, 250 or 250 or 100. Obviously, since we calculated the Nash equilibrium when both the firms choose no investment, they get the Nash equilibrium. So this option should be correct. Okay, now since more information is not given in the question in itself, I am not able to comprehend the other two questions here, but I will go for another thing that I want to make it here clear. Obviously, when both firms choose no investment, they are at Nash equilibrium. But is Nash equilibrium a Pareto optimal choice. Pareto optimal choice. Now if we concentrate on the payoff matrix, by Pareto optimal what we mean? We say a situation is Pareto optimal or Pareto efficient when if we can increase that is the certification of one player without decreasing the certification of another player, or we can make one person better off without making another person better off. Is Nash equilibrium this strategy when both the firms choose no investment and Nash equilibrium? Let us find out if we concentrate. Okay, so if we see here, if both firms come to an agreement by somehow that whatever happens, they will both invest. They will both invest. Okay, that means if they cooperate with each other by an agreement or anything else, if both choose to investment, can we see that 200 is less than, that means 225 is greater than 250 and 225 is greater than this 200. Okay, so here we can see this 225 is actually a Pareto superior or Pareto improvement over this Nash equilibrium choice. That means if both firms decide by whatever means, by an agreement that whatever happens, we will both investment, both are better off. Firm 1 is also better off, they get 225, and firm 2 also gets better off. So that means this Nash equilibrium is not a Pareto optimal choice. Okay, Nash equilibrium is not Pareto optimum. In fact, in this case, investment when both choose is Pareto superior or Pareto improvement over this set of Nash equilibrium. Okay, so other questions that I can recall, the two questions were also given, that is if there is some kind of under investment problem, or how can we avoid the under investment problem. That means when both firms choose no investment. So it can only happen if both the parties came to an agreement that both will investment, then they will get a Pareto superior outcome. So that means if government sets safety standards that will force both the firms to invest, I guess that makes sense here. That very option was given. But in the last option, we were also being told that safety investment by one of the firms in this industry, what happens to the wage rate of the workers? I'm not able to comprehend them, that very question, so I'm really sorry for that. I hope whatever I can make out of this, I made justice to this question. And please share, comment, subscribe this channel, because I make these videos free of cost. I don't charge even a single penny for these videos. I don't have any paid batch like others do. So whatever I know, I throw it on the YouTube, and your feedback is some kind of, what I can say, reinforcement for me to make other videos, or that motivates me to make useful stuff for you people. Okay, thank you.